So I'll start recording this. It'll probably be part of the beginning of today now. So because I started recording, let me just reiterate, we're going to be talking about what the structure of our front-end app is so we can understand sort of what references what, how it's all put together. So like any web server, the first thing we serve up is this index.html. And let's actually, we can even draw that. So it's like, this is, even though we're using a dev server, this is literally my server. And then this line I can do like that. People commonly do this. This line is going to represent like the internet. And when someone asks for whatever the URL is, so it could be localhost, port 5143, or it could be the actual name of your website, www.mywebsite.com. When they make that request, what we're going to give them back is this file. We're going to send them back this file. So it's like someone made a request for the URL. I'm not going to really show that, but then we serve up this index.html file. And that's all we're serving up, one file, index.html. And as we saw here, this file is pretty empty. It really just has two things we care about. One thing in the body is this empty div. So it's empty, but it has an ID of root. And the second thing is this script. And like any other script you include in an HTML file, by including it, you're actually running it. So that's what we have here. I'm just showing this ID root here and that we're running this main.jsx file. Okay, so now let's look at our main.jsx file. And what is it doing? Well, we're importing these libraries, or these two libraries, because we want to use them. And then we're importing our own thing called app, which we'll look at in a second. And we're even importing some CSS. So when we import that CSS, that's as if we just added it to the page. That's like a fancy thing Vite is able to do for us. So the first thing is that just like we have a main.jsx here, now we also have, in index.css. So there's like two files being included now. But that's only for the CSS file. For the other ones, we're still running main.jsx. And when we run main.jsx, the first thing we do is we say, okay, get this element called root, and then do some React stuff to associate that root element with this variable now called React root. And then at that root, render our top level thing called app. So what all of this does basically is it's going to get that root and put as a child of the root this thing called app, which is our own component, and that's not. But HTML doesn't really know about that. It's just a React component, but it turns into HTML. So we'll represent it like this. So going back here, after main.jsx is finished running, we don't even have to think of it as being included anymore, even though it is. But it's done running. But what happens is now this div here isn't just a div. It actually has app in it. And from now on, we don't have to look at, like everything is just going to happen through React components. So now we actually can look at app and what is app. And at this point, maybe I want to make this bigger. So, these files, I can just sort of, move them over here. We're just saying like, these are just these sort of like other resources that were included. I'll just do it like this. So basically, these are just like multiple different resources that are being included, but I really just want to blow this up so we can actually see what our page looks like at this point. So right now it's just div ID root app. Well, app is a component, which means it's represented as a function. So coming back here, I look at that one thing I just rendered app, and because I set it up here, it's going to be within that root element within the HTML page. So it's as if like we open this up and now there's something in there called app, but of course, HTML doesn't know what app is. So it's really all happening at the React level, but it's being, injected into that element root. So now let's look at our app. I can just click on it. So this is what my app looks like right now. It's a function and I'm exporting it default, which is how I'm referencing it inside of here like this. So I'm importing it as the main thing from that file. And over here, I'm exporting it, but it's just a function. And by the nature of this function, we're going to run it. So these hobbies will be like, that's just a regular array. And then this is what it's going to return. But anything where it sees these curly brackets, it's going to treat it like JavaScript first. So it's going to take that array, it's going to map it. And what that map ultimately returns is a list of these LIs with the data filled in. So when this is done rendering, it's going to look like, I'll just put it here so I can see it. We mapped each one of these hobbies. So it's going to look like this ultimately. 1, 2, 3, 4. And the indexes are going to be like 0, 1, 2, 3. And it'll actually look more like this because ultimately it's HTML, not React eventually. And then we're going to have each hobby there. So I'll replace this with dancing, kiting, surfing. And it looks like I said dancing again, but that's okay. Okay, so this is what gets returned from that function when it's ran. So copying all this now, that's the output of app, and it's as if, that was put inside of here. So wherever app was, it's replaced like that. And let's just show that in our Scala draw. So wherever I had app now, replace that with this. But I imagine what you're most curious about is like, what if we have like another component? So let's say we had that. Let's say, in fact, when we did app wasn't alone. Let's see, we have a component like profile, right? There's a whole bunch going on here. But let's use it. So we're going to say we're actually, within app, we're going to import, profile. And then maybe right after my list of hobbies, just this arbitrary page, I have a profile. And because of how profile is, I'm actually going to provide it some props like name, image URL, hobbies. Is there anything else to be concerned about? No. So let's say I provided it those name, image URL, hobbies. So name equals Ben, image URL, is that what I called it? Because those names have to match up. Let's just say, www.google.com. And hobbies was a list, right? So for hobbies, I'll just pass it the same list of hobbies I had up here. So now not only are we returning this stuff, we're returning this other thing, but we do the same thing where we take this profile, we run that function, and whatever is returned from that function, that's what gets put in place there. So for right now, we'll just say, oh, well, actually at the end of that UL, I have this thing called profile, but ultimately that's going to be replaced. So maybe I would do it like this just to put, keep it from overflowing the page. Okay, so this profile, though, it's not HTML, so it has to be replaced. That's what, React is doing when it renders something. So it's sort of like when we, back in main.jsx, we're rendering the app, which means run that function and replace it. And by rendering the app, we run the function, we replace it with everything in here. But if it itself encounters another non-HTML thing, it either encounters something like this, or it encounters, a component, it'll also render that. So now let's look at the definition of profile. Okay, so we'll run this code, including like a console.log, including creating this function, which we later reference. And now what we're taking is this whole thing, but there's obviously stuff in there that gets replaced. So now I'm going to have, I'm going to replace this whole thing. I guess for right now, I'll just, I guess I'll do it in another thing over here, just so I can fill everything in first. So right, this is the div that represents our profile component, but we want to replace all of those things. So React is going to see this and treat it like code. And it's going to see name.length, which in this case was Ben, and that is greater than 0. So because that's true, we look at, we just include that next thing. So this will be in there. If it was 0, it wouldn't be in there. And then we replace our name with the name Ben. We replace the image URL with whatever it was, which was, www.google.com. We replace hobbies 0, 1, and 2 with whatever I passed in there, which was like, dancing, kiting, pottery. I don't remember. Doesn't really matter. And then this on-click handler, like this is where that transformation is happening. That's an actual function we have here. And because, this, what we're looking at is JSX, it's React, but it's ultimately replaced with something that looks like, something that JavaScript understands, or sorry, that HTML understands, and it'll look like some kind of function that's being called. So it's doing all that work for you. What was that function actually called? On-click handler. So like, it's going to know about all this. Maybe it changes the name, but it's just doing all that setup for you. And now this is what's output from profile. So we'll take that and we'll put it in place of this component profile. And while it is all over the place in terms of this stuff, it's going to look like this more or less. Yeah, I mean, and so basically we're using React to pull in these files, and it's really all happening when we render app, but app will recursively render any component inside of it. And so in doing so, we ultimately end up with an HTML page. And so if we were to run this, npm run dev, and I were to open that up, and we were to inspect it, we would see that, yeah, this is just HTML. So everything is inside of the root, and starting at the root is whatever was in app, and app itself might, include another React component, which itself will be rendered and turned into HTML. So ultimately, everything is just HTML. You'll see this button, and I don't even see an on-click on there, but it's probably set up. So if I were to look in this event listeners thing, and I would look at click, it knows something about click, I think. Not sure. But it does actually work. Like if I click it, something does happen. So one way or another, React is making sure that there's some kind of, it's all set up so it works, but React's job is to take it from being, something in the JavaScript world or the JSX world in the form of React components and turn it into HTML, because that's all a website really understands. Yeah, so I hope that is useful. And we're going to include this, to upload it for today's lecture. But yeah, that would be how files are pulled in.
Awesome, thank you.
Cool. Just looking at the chat right now. So Grace is asking if the CSS file can connect directly with Vite, but others have to connect indirectly through main. Yeah, essentially. So it's not that they're connecting indirectly through main, it's that when you're including main, you're running main. And so anything it includes, it's as if that was included in main itself. With the CSS stuff, I think that's just a special case where Vite understands, like maybe you want, yeah, as Michael says, it's recursion, so that when you're including main.jsx, anything else main imports, it's as if it's in that very file. In terms of the index.css stuff, that's just something Vite is giving you for convenience, because it would be nice to just be able to import a CSS file as opposed to have to write it in that HTML as a link. But something tells me that if we were to look in the head here, it's ultimately, yeah, right here. So it is ultimately adding it into our HTML page. It has to, and it's doing some fancy thing. Like I've never seen that attribute data-vite-dev-id, but it's pointing to that index.css file. So it's setting it up for us, and that's just a convenience feature of Vite, but it would work just as well to not do that and add it as a link. So we could just as well have come back here and get rid of that. And if I go to main, I'm importing index.css. So let me take that out. And once I take it out, if I go back here, yeah, it doesn't look the same, right? We don't have any CSS. If I go back here and I went to my index.html, I could do the classic thing where I just add a link tag Someone remind me, it's like relation equals style sheet source. No, it's href. I don't know why it's always a different thing. And it was dot slash. I don't think it wants the dot slash even. It's at the same level, so it wants just index.css. I believe this will work. Not quite. Okay. I wonder
I think
why.
you do need the dot slash.
Maybe I do. Yeah, you might be right. Let's try that. Still not quite. I wonder why not. Like if I click that, does it know about it? If I say sources, that's a good thing to know about, sources. And it seems to be upset about that. And why is it upset? Because it couldn't find it. Maybe I just want slash, because the idea is slash is the root of my server. And the root of my server is going to be, the root of this project based on how Vite works. Does that work? Okay, well, maybe that's a reason to not do it this way. That it seems like Vite prefers its way. I'm not positive how to get that index.css thing to show. But right, yeah, it could just be Vite doesn't. Yeah, I wonder why not. I'm pretty surprised actually. I would think I would be able to. Oh wait, is it within source? It is within source. That's why. Okay. So maybe if I do like /source/index, now it works. Yeah. So I could do it like that as well. But if I do it that way, I need to keep coming back to index.html to update it. And part of how React and Vite want you to work is that you should just never touch this file. The only things you need to touch in this file are things like, maybe the title or something. And even then, I'm sure there's a way to do it without touching this file. This file is just there to set up that connection to React. And then everything else you can work in the JavaScript world, and that's what it wants for you. So that is why, we might prefer, oh, it was in main. We might prefer to just do something like this.
Ben, I got a quick question.
Yeah.
So you probably talked about this before, but what's the difference between accessing the web page the way we used to through run server and having the 12700 and this one doing it through localhost? What's the similarities, differences, and why are they different?
How were you accessing the server before? Like,
so when we did the run server in the Django, right? You just run server, and then you get the was it 127001, and then you / whatever the web page that you're trying to do.
Yeah.
Here we're doing localhost.
Was that one not localhost? Did it say?
I'm assuming it was local.
What? Well, did it say like 127.0.0.1 or something?
Yeah,
I think it's the same thing, Ivan. I think they're one and the same. Isn't the 127 dot whatever is that our local IP address?
Yeah,
exactly.
It's the same thing. But one's name and the other one is just IP address. It's the same thing.
So in the browser right now, you should be able to go 127.0.0.1 index HTML.
Yeah, so 127.0.0.1, that represents your own computer. I have no idea why they chose that number, but because it's hard to remember, localhost is a shortcut for it. Then the colon represents, okay, after this is a port, because a computer can serve up multiple things, so you might care about the port, just like, in a seafaring situation, like there's not just one port. So it could be you're serving one thing up on one port and one thing up on another port. So in this case, the port that when you were doing the run in Django and we're doing the run in Vite right now, I think it's just, they just default to a random port. And the number that they default to in Django happens to be different than the number they default to in this, Vite world. But ultimately it's just saying, it's as if like there was a hotel with like 1,000 rooms. Well, go to that room. What you want is in that room. So that's all the port is. And yeah, this will work just as well because this, when I say localhost, it's just like a variable. It's a variable holding a number you probably wouldn't remember otherwise. And then this represents, go to our own computer, go to port 5173. There should be something being served up on it. And what's being served up on it is this, file right here. And because it has an index.html in it, that will be the thing that is served up by default. So if I, were to write it explicitly, it will also work. And if I were to write, what was it, index.css, because that's being served up at the same level. Okay, no, it doesn't. Oh, no, it's source, right? Because this whole thing is being served up, I think I could go like that. And as you see, it actually, I think because Vite is doing fancy stuff, it's serving up something slightly different than what we would expect, but still, it's just a file that's accessible. Like if I said source, I wonder, yeah, like you shouldn't necessarily try and access the whole thing in this way, but ultimately that's what's being served up, that entire folder. And so the reason why it was different in Django is just because you were serving something up on a different port. And so, yeah, it's just like something happening simultaneously. Like I could probably show you, for example, if I go here, even though we're not using Django, you'll see there's npm run dev. There's also npm run build and npm run preview. So if I were to keep this open, I'm still running npm run dev. It's serving up on 5173. If I open this up, if I were to say npm run build, what that does is it builds the file. So now there's this thing called dist. It has its own index.html, which you'll see is the same, but it's referencing a single JS file and a single CSS file, which like bundled everything we have together and minified it. It's the same exact app, but it's just good for distribution now, which is why they called it dist. So now that I've run npm run dist, I can run npm run preview, which is another thing Vite gives us, and that will not serve up the file from source. It's going to serve it up from dist now. And so now that's on a different port. So if I copy that and I go here, even while this 5173 is running, I could also run 4173. And even though they look identical, we can actually see here, they're not running the exact same thing. So you'll see like these are different files compared to what's in here. Like this is our dev version, whereas this is our built dist version, and they're running on two separate ports but at the same time. So you can run multiple things on the same computer on different ports, and they're both accessible. And so Django runs on a different port, and ultimately we would eventually just have Django running, and that would be our main thing. And you would hit a certain route on Django, and that would return you your page, which would be like served up from a dist folder. So is that helpful or too much?
No, it is. I was trying to, one of the errors I was having was I was trying to go through live server and I was trying to, go live, and it would open up in a 5500 port, and that would show me nothing. It would show me blank.
You're saying
so when I
trying to,
open that with live server, your index HTML.
Yeah. So ultimately everything has to be served up. That's true. I think the problem is that live server is expecting like live server, so you don't have to write a server from scratch, because that would be, cumbersome. It would be a fair amount of work. But if I try and do live server here, right, it's opening it on a port, but it's just because it isn't aware of Vite, it's probably confused by something. So, right, exactly. And this is why we need all that tooling, because it's basically hitting this thing called JSX, and it's like, I don't know what that is. That's not something that live server is prepared to handle, so it just fails. Yeah. So it's getting.
What if you try 5173, the other port, the port that the
well, I stopped running that, but if it was running, that would work. But I stopped.
Yeah.
If I come back here now and I say npm. Is this actually, npm run dev. Now I'm running something on that port. Now I go back here and I reload. It does work.
Okay.
Yeah.
Cool. Yeah. Thank you very much. That answers a lot for me.
Cool. Okay. So we want to get started with today's class, but I like to give a break, before the homeroom type stuff and starting the class. So let's come back in, let's just give you 8 minutes this time, 9:20. We're going to come back 9:20. CS tape. So I'll see you all in 10 minutes, and I'll stop the recording between now and then. But this was recorded, so it'll be on the video today. Okay, share my screen. So this is our topic for today, state in React. Let me just quickly check our calendar to make sure. I'm sure we have the normal full amount of time. Why isn't this working? I need to stop sharing for a second.
Are we going to be able to code along, Ben, or is this a thing like yesterday?
Yeah, good question. So hold on, we're still recording, right? Yeah. So you probably can code along a little bit more today. I'll show you what it looks like in terms of coding along. So what we're going to be talking about today is state. And if you look in here, we have, this file React useState, which is our markdown curriculum doc. And then we also have example Vite project. So that's what I'm going to be working out of. And I have that open on the other screen. So let's look at it. Here's what example Vite project looks like. We don't really need to dig into main.jsx because that's all set up. I'm just serving it up, and app.jsx is our entry point. So there's a bunch of individual things I talk about, but basically I just comment them in and out. So basically to talk about it, I'll be commenting out, commenting in. And a nice thing about, if you're in VS Code, you can just do like command / and that'll comment in and out. And you'll notice that comments are a little different in React because if you just had a / there, it would get confused. And so it likes this approach where you wrap it in the braces and put a comment inside, which is, not going to render anything, but it will comment it out. So what I'm planning on doing is commenting these things in and out. If you're trying to do this from scratch, it's going to be a little harder, but you'll see that each one of these things is sort of contained in some way. So it's really up to you. I mean, in general, programming stuff in real time can be difficult. Maybe we will, maybe just to see it, we'll do that. We'll just do something. We'll do a Vite project from scratch just so we could say, here's how you would, create something from scratch. But then from there, I will do everything, in a component like this. Does that sound good?
Sounds like a plan to me.
Okay, cool. So going back here. Right. So what we're going to be talking about today is mostly state. And state is an idea you're already familiar with because every programming language involves this concept of state. If you say, let x equals 4, and then you print it out, and then you say x plus equals 1, and then you print that out, the value of x has changed. That's state. State is this idea that things change over time. And if they didn't change over time, computers wouldn't be too useful because, you'd only be able to see a blank screen. It's only interesting because you can update what the screen shows. So our goal today is to make React state aware, and that's what makes it React, right? That's what makes it reactive. So what we showed yesterday was that we could use some, initial state to inform what our page looks like. But what we want to get to is that we can have like buttons that, if you click them, it's going to update the state. And importantly, the page will react in response to that update. So you'll see that update reflected on the screen. And in order to get there, we're first going to talk a little bit about this idea of pure functions, just because React is probably a little strange to you in some ways. Its patterns are, maybe different than what you've seen, like using like the map instead of the for loop. And a big reason for that is that React takes a lot of ideas from this area of programming called functional programming. And functional programming is not a language exactly, it's a paradigm. And so the paradigm you've been using for the most part is what we call imperative programming. Object-oriented counts as that. But imperative means you're using if statements and for loops to do things. And in functional programming, you have this idea of a pure function. And the idea is that as much as possible, you want to keep your functions pure. And we'll get into what that means essentially. And then we'll see how we have these different hooks. React has this idea of hooks to add functionality, and one of them is called useState. We'll talk about that a fair amount. And then eventually, okay, this shouldn't be here. And then eventually we're also going to mention, I'm realizing some of this is a little messed up, but eventually we're going to mention another hook called useContext, which is like useState, but a little more powerful for certain situations. So that is our goal today, to add functionality. And what I mean by functionality, if we're going to look at, like, you know, I have this app here, I have it running right now. So I just have this checkbox, right? If I look at that checkbox, this might not seem so impressive, but here I have a button. And when I click it, this other thing knows that I clicked it. And when I unclick it, this part knows I unclicked it. And this is powerful because you want this to happen. But if you're in HTML, CSS, and JavaScript, like the vanilla version, you have to be able to, like, you know, have an event listener for this. And every time it's clicked, you have to target this element and say, hey, I want to update what that element looks like. It's very manual. And with React, we're going to have it be a little simpler, where every time you click this, it's just going to know, okay, re-render the page. And, you know, this will update. So it's easier just to see what that looks like. And you know what? Actually, before we start doing the lecture content, we probably just want to see it just to get a sense of where we're going. And like Ethan said, we might want to, like, you know, see how we would do this from scratch. So if I were to go back here, let me say I'm going to go to uniform assignments. That's just where I'm going to put it. And just like I'm going to create a Vite project from scratch. So can anyone remind me how I do that? What's the npm subcommand?
Create Vite.
Yeah, create and then Vite. It's going to give me some options, and I'm going to name this example useState. And I'll call it, and I'll choose React, I'll choose JavaScript. Great, it made it. So I can go here now. And the first thing I want to do is install my dependencies, because it's going to need things like React. It might take a minute, sometimes it does. And then I can do npm run dev. And now if I were to click this, I actually see, you know, this sample Vite project, and you'll notice Vite gives you a little useState already. That's how it's able to accomplish this. But let's make that ourselves. So I'm going to leave this 5174 open. Oh, interesting, because I have two things running. It just chose another. So I'll leave this 5174 open. And there it is. Okay. No, where was I actually doing that? Give me, where did I have, oh, sorry. Sorry for jumping around so much. Coming back here. What I want to do is I want to open that like this, so we can actually see it. And I'll do npm run dev. And the first thing I want to do, I'm not going to delete any of the files because they can stay there, but I want to go to app.jsx and I want to simplify it just so we have a blank starting point. So I'm going to remove everything here. And I'm going to remove this, which we'll recreate in a second. And then let me just remove everything in this div besides the top level thing. And so now this is all our app consists of. In fact, I'm gonna keep those parentheses there. So this is what our app consists of. And if we wanted to see that, now it's just a blank page. So from a blank page, we might say, hey, I want to make a counter, basically. It's, you know, this app doesn't sound very useful, but we want to show a count and we want a button that every time we click it, it updates the count. So let me start doing that as if I don't have state. So I want to just make something that shows the count. How would I do that? Let's just say I had a variable called like const count equals 0, right? So I want to show that value. How do I do that?
Just do like a header tag with a count.
Yeah, and I can't, if I just write count, of course, just going to see the word count. So I actually want to, because I want to treat it like JavaScript in there, I wrap it in these escape brackets. And now when I save it, I actually see 0. Let's see if we can center this just to make it nice. Oh, I forgot I'm not using class name app. You know what? Not going to worry about it. We'll just see it all the way here. That's okay. And now I want to make a button to go with it. So I'm going to make a button, and I'll have that button say click me. And if I save it, we already have a button now, which is cool. And I can click it, but it doesn't do anything. And just to see this work, let's actually update our console. So let's make it now so when I click it, we like at least write, you know, the contents of the count. So how do I associate this button with some kind of, you know, on-click handler?
Say on click.
Yes, we'll do, oops, how did I get back here? Okay, so we're going to do on, and then notice it's going to like start auto-completing stuff for us. We want on-click with the capital C, the camel case, and then it made the little brackets for us because what we're going to put in is a function.
I don't think you're sharing, Ben.
Oh, that's what just happened. Okay. I accidentally, right. So yeah, so we're going to do the on click, and we open up the brackets because we want to put something there. Well, what do we want to put in there?
A function that increases the count.
Exactly. Yeah. And we could always write it in line like this. Like I could say console.log, you know, count. So it's taking a function. We're just doing an inline arrow function. It takes nothing because, you know, the click, we don't need the event, but the click will execute the function. We'll write count to the console. And this will work. If I click it, we're just going to see 0 over and over again. That's why it's showing this 14 here, because it just printed the same thing over and over. I can make that bigger if that helps. Okay. But it would kind of be easier to have, you know, an actual function like that we pull out. So over here, I'm going to make a function, and, you know, we could do it as an arrow function. We could do it as a, you know, a regular function. It doesn't really matter. But I'm going to do it this way. So I'm going to call this, you know, on click handler, and it's a function, and open up the body of the function. And in that function, I'll say console.log count. And then I'll reference the function like this. That's going to grab the whole function and make it the on-click handler. So we should have the same functionality now. If I refresh, I'll see I can click, 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 and it works, but we're not really updating the state, right? So naively, not that there's anything wrong with this, not bad to be naive. It's just you wouldn't, you know, maybe you don't know. You're going to say, okay, well, maybe every time I click it, I update the count, right? So I'll say count, you know, plus plus, or count plus equals 1, the same thing. I'm adding 1 to the count, and then I'm going to print it, right? Okay, that sounds good to me. It's actually going to get upset because this is a const, so we're going to make it a let, but now we're going to be able to update the count, and every time we update the count, we'll print it. Cool. Coming back here, refresh, I click. Now it says 1, 2, 3, 4, 5, right? So that is working, but notice this still says 0. So the JavaScript part understands that I'm updating this variable count, and it's able to recognize that in the click handler. But the nature of this JSX thing is that it's always showing count, right? Well, count updated. Shouldn't the value also update? You would hope it would, but the thing is, React has rules, and the first rule of React, we look at, you know, our main.jsx, we're rendering app, right? So we're calling this function app with any props if it has any, and it's returning some JSX, and then it's done. Like any other function call, we call it once, it's done. So the problem is that it doesn't know we want to re-render app. It doesn't know we want to call this app function again, because React has not been informed that when count updates, we want to re-render this because this is still correct. Whatever count is should be here. It's just we haven't told React, hey, time to re-render. And you might think, well, wouldn't it be nice if there was a way in React we could just say like, oh, do this and then, you know, React.re-render. So you might think this is a good approach. This is what Angular 1 did. Turns out it's a really bad approach because if the programmer is the one who's explicitly choosing when to re-render, it gets very confusing what's actually causing the re-render, and it makes it hard to debug things. So React does not do that. Instead, React has rules, and the default rule is once a component is encountered, so we only have the app component right now. Once it's encountered right here. You render it once, and then it's done. It's done forever. So how do you trigger a re-render? Well, in order to do that, React has this idea called hooks. So hooks are a way of adding to the basic functionality of a React component. So my function app here, let me move this up here because I like it all in one place. My function app represents a component, and it renders exactly once by default. And what we've seen with components and props, all of that is the standard functionality of React. But React has this idea called hooks that let you add functionality to the basic format of React. And the way we grab those hooks is we say, we want to import something. So we could import React, we could import React from React, okay? That's the default export of React. We actually don't have to import React. It's done for us over here, and that's good for the whole app. But per file, we might want to import some non-default things. So if we open this up and I start writing use, you'll see there's a lot of things in React that start with use. So React has a pattern where if there's a hook, it starts with the word use. Use this, use that. Each one of these things is a hook, and each one of these things adds slightly different, unique functionality to React. And I've never used use sync external store or use transition. I don't know exactly what those are, but there's certain hooks that are used all the time that are really common. So that main hook, the number one hook is useState, and that lets us add state functionality to our React app. So basically what useState is going to do, it's going to allow us to make it so that when instead of just having a variable that JavaScript is aware of, it's going to be a variable React knows about, so it can re-render in response. And it's got a slightly unique API. I tend to use that word very generally. By API, I just mean pattern of how to use it. So let's look at that first. So I want to make a count with the variable 0. That's what I want, right? And then I want to eventually update it like this. So how do I do that with useState? So the first thing we do is we can write useState 0. And what that's going to do is it's going to create this, React aware kind of, variable, and it's going to start with the initial value 0. But what that's going to do is return some things, right? Because it doesn't make sense unless I store it in a variable. So I want something like count equals, right? But if I hover over this, it's a little hard to read, but we'll see that useState actually returns an array. It's going to return an array of whatever the thing whatever the initial state was, but then also this function, react.dispatch, blah, 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 right? So we actually don't return a single item, we return an array. And so the classic pattern is we immediately destructure that array. So destructuring is like, if I had, a array like 1, 2, I could say const, instead of, if I said const array equals 1, 2, then array equals the whole array 1, 2. Whereas if I use destructuring, I could say x, y, and now x equals 1, y equals 2. And we use arrays in this way because JavaScript doesn't have the concept of a tuple like Python does. So we just use arrays of a specific size and we destruct them to get the individual things we care about. So in the case of useState, it returns 2 things. And so the first thing is going to be that actual value, which we set to 0 initially. And the second thing is going to be a function to update that value. And we, as a standard pattern, tend to call it set and then the name of the thing. So now we have something called count and something called set count. And what you'll see is this will still work in that every time I click this, we're going to print out the value. And technically, we're updating it beforehand. But let's see what happens. So I'm going to save this. So we still see the 0 there. Or let me refresh. We still see the 0 there. And when I click, oh, it got pretty upset. Why did it get upset? Assignment constant variable. So this is something we're going to get into in a second, but this is the pure part of React, the pure functional part. So when I return these, you might notice I did const, right? So count is something that equals 0, and it actually equals 0 forever. If I want to update it, I don't update it like this. I update it using this function set count. And what I do with set count is I just give it a new value. So I could give it a new value like 44 if I wanted. And what happens? Well, initially it equals 0. Then I click. Now suddenly it equals 44, right? And I printed 0 here. Okay, that's nice, but that's not exactly what I want. So what I actually want to do is say, take the count as it currently exists, because count will always represent what it currently is, which is currently the initial value. And then I want to add 1 to it. That's how I want to update it. And this is a brand new value that I'm calling a set count. And what set count will do is first, it's going to update the value held by count. So even the JSX part will be aware that that updated. But second, the reason why you see it is because when you call set count, you actually trigger a re-render, which means React is going to recall this function and it's going to run the whole thing again. And that might make you ask, well, then won't it run this again? And so won't it reset the value to 0? No. So that's where hooks do a little bit of magic. And that's why we'll eventually see there's rules to using hooks that are unlike the regular rules of JavaScript. So that is not the case. This line is only run once, the first time it's rendered. Any other time it's rendered because of, set count being called, or as we'll see in the future, because another hook is called. Whenever there's a re-render, the hooks are not ran again. That only happens the first time. So we have our count, we have our set count, and when we call set count, we're taking the current count, we're adding 1 to it, and we're calling set count to update what it is. And now this will work like we expect. So I'm going to refresh. Every time I click, you'll see it adds. And now I have a counter basically, which is, not so impressive, but still it's something. And it's nice that, it was pretty simple to do it. Something you might have noticed though, is that it's initially 0. I click this, prints 1, but then this is still 0. What's going on there? So that's kind of interesting because I wrote set count here, and then I added 1 to it, but then this line ran, right? So what set count is doing is it's saying, okay, when this function's done running, then trigger a re-render. But by the time this runs, count was still 0. So that's a little tricky thing that sometimes you will encounter. But the main trick would be like, you just don't rely on that behavior. So if I wanted to print it, I would print what it initially is, and then I would call set count. Or even better, I take it out entirely. And if I want to know what the state of something is, I just put it down here, and then this will represent the state every time there's a re-render, because when I re-render, I run all of this. So this will represent it initially. And then when this is clicked, we run this, which will add 1 to the count, and then it'll trigger a re-render. So on that new re-render, not only will this be updated, but we'll also print this again. So we'll see that. You'll see I printed 0 initially. It's printing it twice because of that React strict mode thing. But every time I click it now, we see it reflected as we expect. Cool. And that is the essence of useState. And now we're just going to dig into that more for the rest of class.
Ben?
Yeah.
Is that what you meant by not using loops and having to use math instead?
Yeah, that is part of it. So the reason why, if I come back here, okay, so why do we use map instead of loops? That's because React is what we would call, so along with this idea of functional programming is this idea of declarative programming. What declarative means is what you see is what you get. So imperative means what you do is what happens. Declarative means what you see is what you get. So the cool thing about React is I didn't update this at all. What this says is every time this function is called, every time you render this component, it's going to look like this. It's going to be a div with class name app. And then this is going to have something in it called count. And this is going to have something in it called onClickHandler. Now, if those values happen to update, this will reflect that. And so we only ever write this once. And then outside of it, we might handle the updating. But this reflects the entire component as it will always look. And then it's just the values might actually change depending on, anything that is escaped like this. So the reason why you use map is because, theoretically we could have something where we say, we have a for loop and that for loop does something. It like prints something out or something. But there's no way to write a for loop inside of here because this is ultimately like a string basically, or an object. It's a thing already. And if we want to add something to it, it has to return something. And if I say for, let x equals 0, x is less than 10, x plus plus, like maybe I would want to do this and say like, for each one, we're going to have like an li, and that li is going to have that value x in it, right? But you see, it's already yelling at you. It's saying expression expected. So the problem with this is that a for loop does something. So you could like print something out in a for loop because printing is doing something. But it doesn't return anything. Like if we just do that in Node, so if I just like open up Node for a second to see it, if I do for, do I really want to rewrite all this? If I were to write something like this in here, oh, right, it's going to be confused by that. If I were to write a for loop in Node, and maybe I'm going to say inside of that for loop, I'm going to say console.log x, and then I'll end it. So that printed all of this because we're, in the console, and you see that it printed it in orange. But notice down here, actually, if I highlight it in white, it returns something. When you run a for loop, it returns something. Because we're in the REPL, it returns undefined. It doesn't return anything useful. What I can't do is something like this. I can't have a for loop in which I have the for loop, and maybe I want to say, if it was like an expression, I would just say, okay, return x for each thing in the for loop, and then close it. And maybe I would expect that might return a list of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't. Interestingly enough, it does evaluate to the last thing. That's interesting. I didn't think it would do that. But that's not really what we wanted. So instead, if we want something like this, we would have to have like a map of some kind where I might say like, I actually have no idea how to do this now. Is there a range in JavaScript? But if this was Python, you basically make a range, you make a list from 0 to 9, and then you would, map that in some way. But the end result is that if I want to do something a certain number of times, I can't write it in a for loop. I have to write it like a map. So I would have like 1, 2, 3 dot map. And then I would say for each thing like num, and then I would have the index, let's say, for the sake of that key. And I'd wrap these in parentheses so that I could do it on the next line. And then over here, if I wanted, I could say, here's an li. Each li has the num in it. Each li, just for React's sake, has this key equal to the index. And now we're actually going to have these 3 li's there because this returns something. This, when we run map actually returns a value. And so we'll actually see that there. So it's yes, I mean, long answer short, it's related to this idea of functional programming and purity, which is why we use map and why we use the ternary operator, because all of those things are expressions. They return something. Whereas statements like if and for loops, they do something. So it's a very like specific distinction, but React only wants things, it only wants expressions, things that return something as opposed to do something. And that's part of the reason this is how it is.
Gotcha. Thanks.
And I see Jake is asking, could you use a for loop to make a helper function and then pass that in? I mean, theoretically, you could do something like this. You don't generally do this because this makes it so that it's not all readable in one place. But I could write something like this, where I could say, okay, open up this loop and then say render list, right? And then render list maybe. And then maybe render list is an actual function. So I would say like const render list takes nothing. And then what render list does is maybe like, it'll say const list items, and I'll make that an empty array. And then I'll say for let I equal 0, I is less than 3, I plus plus. For each one of these things, maybe I'll say list items dot push. And I can actually use, because this whole file is JSX, I can do something like this where I say each thing in there should have an LI. That LI should have maybe a key. I mean, let's just say we're just going to do it like this. Will this work? I wonder. I don't, maybe not. I don't know if it's going to understand it in this context, but I'm basically making this list where I'm putting the LIs in there. I doubt this is actually going to work. And then when I'm done, I could return that whole list of items. And now React, when it gets to this point, it's going to call this function because whatever's in here can be JavaScript. So it's going to call this function. This function does return something, which was a list. And this list was built up over time using a for loop. So does this work now? It wants the key, but otherwise this did work. Yeah. So if I were to, just say like key equals I, okay. So now we're not going to get an error, and this does work. So this approach works fine. And if you really want for loops, you can use this approach. The downside is that now when I read through what my component returns, I have to look, oh, well, what does this actually do? And now you're splitting things up a lot. And so the way around that is to use map, because then it's all in line. It's all in one place. But there's nothing inherently wrong with doing it this way. And in the early days of React, that is how people did things. So hopefully that's helpful.
I know, I noticed in the React docs, the website, they did split it up. They did the mapping outside of the return function, and the return anyway. Just to.
Oh, really? Yeah. I mean, share that because maybe there's something I should see. But I guess, and like everything else in programming, my attitude is your goal, first and foremost, is to make it work. So no one knows what your code looks like. People know what your website looks like. No one knows what your code looks like. What your code looks like matters for the other programmers on your team. It matters for yourself in terms of maintainability. But there's generally no awards for incredible code. Only programmers value what it looks like. Users only value it insofar as that good code allows you to, make the app better without it getting worse. Like you're not reintroducing bugs all the time. But if you find a pattern that works for you, that works for you. If someone tells you what a best practice is, that's nice. You could follow it. But the best practices, the true best practices are the ones you do it yourself. You do it a way that works for you. And then maybe over time you realize, oh, there's some issue there. You find it another way. So the true best practices are the best practices that have proven themselves for you. And the only reason to listen to other people is that, just like good advice in the world, it might save you from making the mistakes directly yourself. But the downside to good advice is that maybe it's bad advice. Maybe you would do better, making a mistake yourself and finding out, oh, like, your path makes more sense. So like people are going to tell you go to college, but maybe you know exactly what you want to do. You want to be a professional jet ski person. And, college isn't going to help you for that. So if you know what your goal is and you know how to reach your goal most effectively, or you think you do, going your own path will at least, give you experience and you'll learn something. And that best practice might, be appropriate for most people in most situations, but it might not be appropriate for you. I see Dennis is asking what that line means in the console, install hook.js. I think that's just coming from the fact that if I come back here and I go to main.jsx, we have this react.strict mode. So that's designed to like help you catch bugs. But if I remove that, it's still there, but we're just rendering app. Now, if I reload, you'll see I'm only ever printing it from one place. So that install hook thing is just some kind of like thing to help us catch bugs that react.strict mode is doing. But if you find what it's doing confusing because it's printing too much, just remove it. Cool. So I think that puts us in a pretty good place for starting the lecture now. I want to give you guys another break, but let's just see when we come back. We'll come back pretty quickly. Our lecture content is over here, and we're going to start in a pretty, general theoretical place where we're just talking about state as a concept. And then we're going to be using this example project, which is in the same folder as day 2, just to go through these different situations, starting with a basic one where, they're all ultimately being rendered in app, but checkbox is my very basic one. As you see, we're not using this stuff at all here. We're just jumping into checkbox, and then checkbox contains everything. So we're going to see that when we come back. Let's give everybody 10 minutes. We're going to come back at 10:07. How does that sound? Cool.
We are going to go more in depth into state and useState and all that.
Nope, we're not going to go more in depth. This was the entire lecture. I'm joking. We will go more in depth over the next 2 hours.
Okay.
Yeah. So that's everything that's here. Like, as you see, here's basically I have, this one way of doing it. Then there's this slightly, basically, yeah, there's a bunch of different situations involving state or involving this thing use context, which is in a more advanced version of useState. So we go through a number of different situations.
Okay, cool. I had a couple questions about state, but if we're going more into it, then I'll save that for later. Maybe it'll get answered.
Okay, sounds good. Yeah, we will encounter it because, yeah, there are interesting things to consider that we'll encounter when working with, useState with lists, for example, or objects, things like that.
Okay, cool.
All right, see everybody in 9 minutes now. Okay, we're back. Cool. So what we're going to talk about now is this concept of state. We're just going to start with the concept of state itself, which is something you've encountered all along. State can sometimes be referred to as the word context because that's what it is. So context, I guess, let me just show this in Node first. Context is the idea that when your code executes, it executes in a context. So if I were to write, let's say I'm going to open Node. Originally, there's no context. So if I say console.log x, it doesn't work because it says x is not defined. And yet, if I were to say, let x equals 44, now there's something in the context called x equal to 44. And if I run the same exact line, now I do get something. And the line did not change. It's that the context changed. So variables and, yeah, basically the very concept of a variable is associated with this concept of state or context, because a variable assumes something exists somewhere. And if you're trying to update that thing, it's the same thing, as in, if I want to update X, X has to exist. And when I updated X, now this thing in the background changed. And if I recall that same line, once again, it has a new value because the thing it's referencing has changed. So now for a second, let's think about context-free programming. So if I'm creating a function, this function x plus y takes two, I mean, this is obviously a trivial, weird, contrived function because we already have plus, so why would we make this function? But just to demonstrate, I have this function x plus y. It takes two variables or two parameters, x and y, and it just adds them together and returns that. So when I called x plus y here, called it with 1, 2, stored it in result, and I printed that, it returned 3. And then I do that once again. I called x plus y with 1, 2. Internally, it computes 3, returns it, stores it here, and I print that same thing. So this probably makes sense. There's nothing new here. But the point here is what kind of function x plus y is. So x plus y returned the same value no matter how many times we ran it, no matter how many times we could run it with the same inputs. And you can kind of think like, well, in this case, I'm just printing it, but no matter what I did in between, anytime I call x plus y with 1 and 2, it's always going to return 3. Why is that? Well, it's because x plus y is what we would call a stateless or a pure function. It's pure because it follows this rule, which is an academic term, but I like it, called referential transparency. What that means is that no matter how many times you run this piece of code, it always returns the same value. So the reason for that is that this function x plus y, its entire meaning is determined by its inputs and then by the body of the function. So what x plus y does is entirely contained within the definition of the function. That's not always the case, though. So if we come back here, let's see an example of an impure or a stateful function. So in this case, we have this thing called myList, which exists outside of the function. And when we call add to list, we give it an input Nancy, and it updates that myList and then returns it. But then notice when we call it again, we actually got a new result. That result is not the same as the previous result. And that's because add to list references something outside of itself. So in the first case, the inputs were the only thing that mattered, whereas add to list, it's not just taking, the parameter name. It's taking the parameter name, but then it's using it to modify something outside of it. And actually, in this case, it wouldn't even matter if we passed myList in directly because myList is being mutated. Even though it appears we're passing it into the function, its whole existence doesn't live in the function. So this goes back way back to like week 2 when we talked about the difference between pass by value and pass by reference. When we pass something like, a string into this function has its own copy of that string. Whereas when if we were to pass an array in here, well, that array, we're not really passing in the array, we're passing in a reference to the array. And so the thing we're modifying could be shared by other people, could be affected by other things. And so the problem with that is that now the definition of add to list Nancy is not entirely determined by add to list Nancy. It's determined by add to list Nancy and the context in which that function was run. So over here, the context of this function is that there's something called myList that's empty. The context of this function being run is that there's something called myList, which already has something in it called Nancy. And that is the core idea between pure and impure functions. And that's kind of the basic idea that all of functional programming is based on. So before moving on, let's ask any questions about pure versus impure and this idea of referential transparency, which is a big fancy word for what I just described. I see in the chat, Eric is mentioning like a holy war to purge impure functions. The funny thing is, it's the same, like in an academic environment, people who are very into functional programming, they talk that way, as in, you know, I mean, it's almost built into the word. Like purity is like, oh, we have to protect the purity. And the reason why that first kind of function is called pure and this one is called impure is that the problem with impurity is that it spreads. So anything that we're to call add to list, or sorry, anything that we're to call x plus y, because it's a pure function, x plus y always functions the same no matter where it's called. This property of purity is maintained. Whereas with add to list, not only is add to list itself an impure function, now any function that calls it is also an impure function. And that's the reason why you run into bugs generally in writing programs. Those bugs are generally stateful bugs. And by stateful bugs, what I mean is that that bug happened because you called something that called something that called something. And what is happening might have worked in one context, but because something happened while running your program, some value, it relies on change. Now, when you run it, you get a different result. And that's not to say that impure is bad, because how could you write a pure database, right? A database is all about updating values. And in fact, if all we have is pure functional programming, your screen would never change. A computer would be meaningless, because we do live, or at least we believe we live in time. Things change over time. Otherwise, the concept of time wouldn't be useful. Sorry to get so philosophical, but this idea of state is inherently tied to this idea of time, which is inherently tied to this idea of change. And we actually want some things to be impure because we do want there to be change, and we want that change to be reflected in the world over time. But the idea of functional programming does not mean that you never change things. What it means is that you're very specific about when you're changing things, when you're being impure, and otherwise you're trying to be pure to like sort of contain statefulness so it's trackable. So yeah, I mean, this is so abstract, it might not be very possible to ask questions, but let's pause for a minute if we do have questions. Okay, fair enough. Well, let's see how this idea of pure functions applies to React. So in React, a component by default is pure. That's why we have this distinction between components and components that use hooks. So a React component by default is pure. And what we mean by that is that the inputs entirely determine the output. So currently there's no inputs, there's no props. And so no matter how many times you were to call profile, no matter where you were trying to render a profile, it would always return this. And similarly, even if we do use props, as long as the props have the same inputs, we would always get the same outputs. So both of these situations, with no props and with props, as long as we're not using any hooks, these count as pure components. And there's actually a efficiency positive as well to this idea of purity, because if my function returns the same value no matter where I run it, as long as the inputs are the same, that means I can do what's called memoization, which means that once I run it once, I save the result. The next time someone calls that function, the next time someone tries to print a profile, I don't actually run the code. I just say, well, because I know it's pure, the output is always identical given the same input. So if the inputs are the same, I'll just return that output that I saved somewhere. And React does that by default. This is not something you have to do. If you ever run a regular React component and you give it the same props as before, it's going to return the same code. So let's actually see that. If I were to, I guess I'll go back here and open that sample project I was using. Sorry, I'm just going to go back here. I had that in uniform assignments and I called it example useState. Okay, let's open that up. npm run dev. And this is what we have running right here. So just to see this, let's say, I'll just add it at this level. Let's say I had another thing called profile. And it looked like this. Okay, so my profile takes two props, name and image URL. Just to make it simple, I'll just make it like name and age or something. 3, say age, and that's also passed in as a prop. And now let's actually, in app.jsx, include some of these. So I don't know that I need most of this right now. I guess I can leave the counter. But I'm going to replace this with a profile, right? And we want to import that. It looks like it did it by default. And that profile, it only really makes sense if I give it a name and an age. So I'll give it a name equal to Ben and an age equal to 35. And I'll save it. And when this component is rendered, it's going to produce this HTML with, these values filled in. And that's what we see here, Ben and 35. That's one thing. And we might call it again. We might say profile name, Jake 99, old Jake, old Jake. And then we see that, okay, old Jake 99. And because the inputs change, which inputs in a React component are props, it's going to actually rerun this so that it can produce something. But behind the scenes, every time React runs something with new props, it saves it because it knows about this, pure property. So if I were to, for whatever reason, want to render this again, and this might seem, like, why am I rendering it again? Well, in this case, it's kind of contrived, but let's say you were jumping between pages. Well, maybe you rendered something once, you went to a new page, you rendered something else, but when you go back to that old page, maybe it's going to show this again. But you don't have to re-render it because when I do this, even though we can't see it happening, React does not run the function profile again. Instead, it says, oh, I've seen this before. I've seen profile with these props. I see that profile is a pure component. So I'm just going to take whatever the output was there that I saved, that I memoized, and I'll output it once again. So in this case, this time it was actually rendered. This time it just took whatever was output from here and put it here because it's already been done. So, Chris, I think you're asking a question. Can you ask that question explicitly? It might help.
Yeah, I was just confused on the definition of purity. I wasn't sure I got it. I thought essentially if you're taking a number, numbers are pure because 1 + 2 always equals 3 as far as I know.
Well, in part, it has to do with numbers, but not entirely. So if I look here, this is pure because it's what makes something pure is that the inputs totally determine the outputs. But let's say I took some similar code. Let me go like here. And let's say I had something that instead looked like this, where I said X + Y + counter, right? So I'm going to have this in a couple places. I'm going to call it here and I'll call it here. And then I'm going to have behind the scenes something I'm going to call let counter = 0. And then the body of this will say X + Y counter. So the first time I run this with 1, 2, I'll print it, that returns 3. And it returns 3 because it's 1 plus 2 plus 0. And theoretically, if I ran this again right away, it would be the same thing and it would produce 3. But this is an impure function. Why is it an impure function? Because the inputs do not entirely determine the outputs. And that's because there's this thing we're referencing outside of the function called counter. And even though we didn't encounter this situation yet, we could. And that situation would be this. In between, someone says counter plus equals 44. Now we run this, now we run this same code. But when we run this code, 1 and 2 are the same. The inputs are the same, but counter, which it relies on as well, has changed. So now it's, 47. And that's what purity versus impurity is. Something is only pure if the inputs entirely determine the outputs. If you're relying on any outside state, that is not the case. And what can get confusing is that even if something like an array is passed in, because an array can change behind the scenes. So let's say I also passed in an array and I said x plus y plus like array dot like sum. Is that a thing? Or let's just say array 0 plus array 1. So we're also passing in an array now, right? So I might change that to array, take these lines out. So now I'm doing x plus y plus array, and I'm passing all of it in. And then here, maybe I would pass in an array that looks like 3, 4. And so what that's going to do is 1 plus 2 plus 3 plus 4. And if we did that here as well, if we change nothing, then yeah, it's going to be the exact same thing, which 7, 8, 9, 10. So in both these cases, it's 10. The problem is it's also impure because in between these two calls, something could have changed. Someone could have said, well, I guess this only works if I have it called like, const array equals 3, 4. And then in both of these situations, I'll just call it array. But the problem is that if I do it like this works, but array can change out from under me, where someone could say array, 1 is now equal to 72. And now this time we say 1 plus 2 plus 3 plus, 72, because that's what array 1 equals. So it's not so easy to just look at it in terms of the inputs. It's really about the fact that the inputs entirely determine the outputs and that no outside force could change those values from you.
Got it.
Yeah. And it only matters so much in terms of how this relates to JavaScript. We really want to think about how it relates to React components. So I'm just looking at the chat right now. Is it still pure if you directly destructure in the component argument? The destructuring part shouldn't matter. It's basically about if something else can change it through a means other, like if your thing relies on something outside of everything that's defined in itself. So the reason why this doesn't work, why this isn't pure, is that if we go back to V2, you might remember like 1 and 2 are passed in by value, which means that internally the X and the Y that it's getting are brand new. It's unrelated to the outside world. It's totally contained within the function, whereas array, it's passed by reference. So something else could theoretically change it in between calls. And it looks like we're calling the same thing, but we're not. And that matters in terms of, right. So I'll close this. That matters in terms of React, because if I look at components, this is a pure component. This is a pure component in part because it takes no inputs, so it always returns this. This is also a pure component because while it does take inputs in the form of props, those props are entirely contained within the function at this point. Whatever you passed in cannot be changed by anybody else. And so it's always going to produce the same result given the same inputs. But I think what I'm realizing is that we don't need to talk about purity too much. It's just to introduce what hooks are and why they have this special rule. So React components are pure by default. But a hook is a way to update it to give it one of these impure abilities. So we'll eventually see there's other impure abilities. So like talking to a server is what we'll talk about tomorrow with the use effect hook. And that's also impure because maybe that server exists, maybe it doesn't, maybe it returns one thing, maybe it returns another. Because a server is outside of the function, of course it is, it's all the way on the other side of the world, theoretically, it's not pure. But of course you want to talk to servers. So same with useState. useState is a way of updating, the context, the state in which this component runs. And so it is impure. But instead of React just allowing you to do impure things, by default, everything is pure. And then these functions, these use functions, allow you to get some impure functionality, but in a very controlled way. And they all have rules. So in this case, we have this checkbox here. Now, so in this case, our checkbox looks like this. And it takes in a label and it shows the label. And we have this input, and yeah, technically it would render something that we could click on and it would update what it looks like, but we're not actually in control of that. We're not holding on to any variable that knows whether this input was checked or not. Whereas in this case, we use useState. And what that lets us do is say, okay, the checked state is false. I'm actually saying the input has a state called checked. And when you click on change, we're going to update that state using the setChecked function that returns. And in this case, I'm flipping it from false to true. And I want to do that every time it's clicked. And then this line here will actually reflect whether it's checked or not because it's state aware. So let's just see that in code. If I look in app, the first thing I'm looking at is a checkbox, and I'm just passing it a label, self-contained. Then we can actually look at the checkbox over here. And this is what our checkbox looks like. We're grabbing useState, just like normal. We're taking props if we have any. But then here, we're actually using that useState. Over here is our initial value, which is what's going to get stored in checked. But then we also get back this function setChecked, which allows us to update that state when we want to. And it's all wrapped in these, array braces because we actually return two things, and that's how you accomplish that in JavaScript. And then over here, we have our input. And so I actually have this value checked, which is built into every input, and it represents, if this is true, then it's currently checked. If it's not, then it's not. And so we're going to make that reflect this. So it's going to be false if it's false. And then we have this on change, which says if there's ever a change, run this function. And so when we click it, or when we check it, or when we uncheck it, this is going to get run, and it's going to run the code, and it's going to update this value checked using the setChecked function. And so checked will now, after calling it once, have the value true. And because we use setChecked, React knows to re-render this whole thing. So now it's going to be checked equals true. And now here for check status, it's going to be true here. So it's going to show checked as opposed to unchecked. And the end result is we have something that looks like, just show it over here. Close that. We have something that looks like this. So we have this box here, and we might even be able to inspect and look at it because this is a useful time to use this components thing. So we have this checkbox here. And you'll see we have some like values associated. So we have the props like normal, self-contained, but there's also this thing hooks, and it says one state false. And when I click it, now one state is true. So it doesn't know the name of it, but because that's just a variable, but it does know there's this thing called state, and it's keeping track of it, and it has the value true now. And so the whole component updated in response. And so that's the essential bit of how you keep track of state in React and have the page just automatically react. So let's pause for a minute. Roger's saying he's lost. That's legitimate. So yeah, let's dig into this because this is the core idea. Questions?
Ben, I'm kind of getting lost when we are doing the useState. I guess just the fact that it's kind of backwards. We're setting like if you don't mind going back to your code real quick. Where it says checked, comma set check equals useState false. I feel like it's a little backwards. Usually we get a variable and then we set it to something. Here is like checked, comma set check. Like what is false saying? Is false saying that checked equals false?
Yes. So
And what if? I'm sorry. Continue.
useState, what you pass here is like the initial value, and that's what's going to get stored in checked. Set checked is just another variable being passed back to you because this is the means by which you update checked. Because if you try to do like, you know, checked equals true, it's not going to respond to that. So set checked is the only means to update this variable.
Where is set check being created?
That whole thing is returned from useState. So useState returns an array, actually. It returns an array of two things. And so this is the common pattern. You have this useState, you pass in an initial value. It returns two things, but you immediately destructure it. The first thing is the actual variable, the react-aware state variable. The second thing is the function that lets you update that variable and re-render as a result.
Okay.
So yeah,
that's preset. The index 1 is supposed to be a preset function that updates index 0.
Yes, exactly. So it's a lot to digest a little in some ways, because this whole thing is your like standard useState, the whole thing. So your useState is always going to take an initial value. It's always going to return an array. You're going to want to always destructure that array to get the two things in it. The two things you're always going to want to name them like this, where the first thing represents what it is. The second thing is just set that thing, because that's all it is, a function that takes one argument and just is whatever you give it is the new value of that thing. And then because these are variables.
Yeah, and down below on change callback, you're calling the function set check and you're passing the variable not checked, therefore making checked false.
Exactly. So yeah, that part is a little confusing. It's sort of like, it's more like this, like I'm saying new value. Well, what do I want new value to be? I could say true and then do this. But the thing is now I can, I can click it once, but no matter how many times I click it, it's going to stay, right? So that's because I said new value equals true. So in reality, what I want to do is take the initial value, use it in some way. So because it is just this value true, I can say this value false. I can say not false. Now it equals true. That's the new value. And then I'm setting check to the new value. And then that's going to work the next time I call it where it's true. Now I'm going to set the new value to false. Now set checked is going to get this new value of false.
Okay. Okay, then can you go through the input type again, like down below, of how that worked?
Yeah.
What's happening?
Let's actually build this up. Like, let's say I didn't have any of this, right? I'm going to take this out. I'm going to take this out. I'm going to take this out. We're starting with a basic component now, and I'll take this out too. This is my basic component, and let's say it doesn't have any of this, right? This is all it looks like. So when I render checkbox, it's going to get the label as a prop. It's going to print this out, and then it's going to print out this input. So I can look over here. I'll reload. I'll look at elements. So I actually see it over here, and I can check it and uncheck it. And if I were to actually like look deep in here, I think that's going to be in like properties. there should be this property checked, and you'll see that should, it's not, why isn't it updating? It might just, not know to update, but this should be getting updated every time I click it, as in it knows, the element itself knows whether it's checked or not. Yeah, so I guess it's just that you have to click away. But the element itself is aware that it's being checked because the HTML element input has this value on it called checked, and that can be true or false, and it is aware of whether it's getting clicked or not. The problem is React doesn't know about this. And so if we want React to be aware of this, well, we might think we could write checked and then make it, equal to something like, naively, we might think we could say like, let checked equal false. And then we'll say, okay, checked is always going to be equal to what that is. And then I don't know, we might hope like what I'm trying to do here would be like what Angular 1 did, which is called two-way data binding, which is like, okay, if this value is false, then this thing's going to be false. But if this value changes, this is going to change as well. React does not do it that way because it turns out two-way data binding sounds really convenient. It ends up being worse because it makes it so it's not clear where the change came from very often. And so React does not do this. Instead, it says, okay, if you want this value checked to, to represent this state as a variable checked, you have to use useState. So the way we do that is the first thing we do is we import useState from React. And now instead of writing let checked, we would say like const checked equals useState of false. That's seemingly what we want, right? But it actually returns an array. And let's say we just wanted that first thing, because you don't, if you're destructuring something, you don't have to take everything. Let's just say we only want the first thing. This would actually work. We'll see if we print it out. Console.log does equal checked, and this will represent that. So I'll refresh and I'll look at the console. We are printing false. See, it's giving us a good error. This is what we're going to want. But when I click it, nothing happens. And that's because we haven't written any kind of update function. And the update function we would want, it's telling us right here, is called onChange. I see you, Chris. I'll call on you in a second. So actually, we are going to want an onChange. That onChange is going to take a function, which if we wanted, we could just write in line. So I'm just going to give myself more space like this, but we could write that function in line. We don't really care about the event, so we're not even going to name it. But this function is going to run every time the checked happen. And maybe we want to say like, checked now, because it is a variable we have access to. We're going to say that is going to be equal to, we want it to be true, but we want it to change every time. So we're going to say checked is equal to not checked. So let's see if this works. Refresh, it's false. Okay, assignment, right, assignment a constant variable. Okay, so let's just try that. We're going to do it with let, just to see if this works. Okay, it doesn't quite like that. But I think the reason is because ultimately, this is not how it wants us to update that variable, which is why we generally set it to const. This is not how we update things. Instead, what we're going to do is there's actually a second thing returned from the useState. And we can name it anything, but we're going to name it set, the name of the first thing, just because we know that's what it keeps track of. So in here, instead of calling, every time it changes, do something, instead we call the setCheck function. The setCheck function needs to take a new value. And maybe initially I'll just say, okay, well, it always is going to be equal to true. And I save that. So now this is going to be false initially. I click it. Now it equals true. I click it again. Oh, it still equals true. It's always going to equal true. It's because I don't want to write it that way. Instead, I want to take whatever the current value of checked is and use it to produce the new value, which then I set check to. So now this will work like a checkbox where every time we click this, we're going to change the value of checked from true to false, or false to true, or true to false. When that change happens, because we're calling it with set checked, it's going to re-render the component. That's going to rerun this. It's also going to make this have the correct value. And so now, refresh, it's going to work as expected.
On change is coming from the checkbox. I'm assuming it's a value of checkbox.
Yeah, so checkbox is just one type of input. Input supports this thing called on change, whether it's, if I created another one of these, it'll still be able to be on change. So let's say I say type text. In that case, we don't say check, but we say value is equal to value. And then the on change here would be its own on change, where we would have like, set value. And I mean, we're going to see that one in a second, but basically, I guess taking these two out, we could see that we could also just have another type of input, and it's also going to be able to use on change. So maybe I'll just write it like that. I'll say on change on this one is going to be equal to a different function. That function is going to take an event, and every time I'll just print the event. But what I care about is basically what was in that text box, and that you just have to learn this. I don't know why it is this, but that's always going to be an event.target.value. So coming back here, we have our first thing, that's the checkbox. But over here, if I start typing hello, every time I type, it's going to update as well. So the on change is just a way of triggering an event every time that input has been changed.
It's like on submit or on click, essentially.
Exactly. So on click is like a specific type of on change. The change was that it was clicked. So if you have an input, instead of like a button uses on click, an input uses on change. And those are all things that are, even in regular HTML, you would have like lowercase on change. And then the React equivalent is this capital, the camel case on change.
Does it use event listener as well, or no?
Does what use event listener?
The JSX. Will it not? Was that like the two-way thing you were talking about?
Well, I mean, you do get an event as an input. It's just we don't need to use it here. But like in this case, we are getting an event as the input. And we can use that event to grab whatever the change was.
Okay, I thought we could use like event listener to change the status, but I see.
Yeah, so we're going to see that in a second, like how we work with inputs, but it's a little roundabout because of this one-way data binding, where we use the on change to listen for a change happening, and then we use that to update our internal React state, and then we use something like checked equals to set the React state. So let's look at that now. This is just explaining the useState pattern, and this is all in the cheat sheet as well. Actually, before we do inputs, let's just talk about this idea of a controlled checkbox, just because I want you to see how this is done sometimes. So in this case, if we go all the way back to what it was, I just want to get back to seeing that. There we go. Yeah. Wait. There we go. Okay. So this checkbox, you noticed everything is contained in here. The state is contained in here. The callback function is contained in here. And showing all the data is contained in here. So it does work as expected. This is what we would call a smart component. So a dumb component doesn't have any hooks. That's what makes it dumb. Dumb is actually kind of smart in that what's good about dumb is that it's a pure component. It doesn't, pure and dumb are the same thing. You don't need to know about anything else, which is good. You get to be dumb. Smart component means it has a hook. It's aware of state, whatever it is, it's able to, it's going to re-render in response to something. So an alternative to the approach we had is this idea of a controlled component, which is almost identical, but we'll show it here. So here, I have a controlled component. The nature of a controlled component is that I'm using props here to pass some data in. And I'm not just passing in the label. I have some useState up here, which I'm defining here. And this is where I'm passing in those values. I'm passing in the checked value. I'm passing in the set check value, which is a function, but that can be used as props too. And then here, I'm actually reacting to that checked. So if I save this, it's going to look almost identical. We're just saying controlled now. And so the question is, how does this work? Well, if I look inside of my controlled checkbox, it's just another component I have. How does this work? Well, this actually entirely depends on its props. We're not using useState anywhere. It so happens to be that we passed in some functions that useState generated. And so this will work as expected now, where it's always going to show whatever was passed in as checked. And when we call onChange, it's going to call that function passed in as props, set checked. It's almost identical. But the idea is that this is still a pure or dumb component because it's reacting to, some state changes, but it's not responsible for making those changes. Those changes happen up here. Everything's contained in here, and we're just passing that data down here. So what's happening is we're going to print that, we're going to render this controlled checkbox, pass it the values checked and set checked. Within here, when a change happens, it's going to call this function. That function came from here. So this is where it gets the update. Checked will, as a result, app will re-render. Checked will have the new value true. That'll be reflected in here. And because the prop changed, we re-render this. And then this is going to change as well. So it looks almost identical. It's just a matter of where the data is, or where the state is being defined, and that you're passing it down. So this works just the same. And the only reason you would want to use this pattern is that in that first pattern over here, everything was contained in checkbox. So if something at this level, at the same level as app, wanted access to checked, it doesn't have it. Whereas in this case, the state is defined at the top level. And then if something needs access to it, including access to update it, you pass that in. But everything, including any of these other subcomponents, could be passed the same data. Okay, yeah. I hope this is helpful. Do people have questions, or, I'm confused is also a kind of question.
So essentially, you're just showing how to pass that data into another component.
Exactly. And you just pass it in with props, but the point of passing it in is that you basically in React, because of this whole one-way thing, you can pass something from a parent to a child. Childs cannot communicate with their parents, and that's by design. And so if you want to, basically you can pass things down, including the ability to update something, but by defining everything at this top level, we can pass down whatever we want, but that means multiple components can have access to the same thing. So I guess here's something we could do. Like we could have a second controlled checkbox, right? And we're passing the same data to it. And so that now puts us in a situation where we have two checkboxes. If I click one, it updates both. If I click the other, it updates both. So that the state is shared. And that's only possible because we're defining it at the parent level, not at the child level. And of course, if you wanted these to actually be separate, you could just define two use states with two different values. But it's because we're passing in the same exact values that it's doing that.
What's the difference between the control checkbox and the first checkbox we used?
The only difference is the level in which the use state is defined. So if we look here, like this is a way to show it. So like here we have the checkbox, right? We click in there, label, props, checked, set checked. Everything's going on here, including this checked status. And so in that case, it's all defined inside checkbox. If we look at controlled checkbox, there is no use state here. The use state was defined in app, and then what it relied on was passed in here. So looking here now, we have our regular checkbox, and only one of these, we have our control checkbox, and they're functionally the same right now. This one turns this on and off, this turns this on and off. The thing to notice is that for this one, it's defined within checkbox. For this one, this line is defined within app. So this line here is still able to access and do stuff with checked. And so if we take this one out, right? Now, and I guess we take this out as well. The idea is we might think, oh, well, the checkbox, you know, controls checked, set, checked. Because it only lives at this level, now this is meaningless. We can't look at the status of check because check lives at a level lower than us. And so it breaks. And so that would be the main reason. Like if you know that something wants to be shared at multiple levels, then you use a controlled thing. Whereas if the state you care about is entirely contained to that one component, it can be defined in the component itself.
Makes sense.
Great. Okay, let me comment these out right now. Move on to the next thing. Okay, so we're at 10:55 right now. We essentially have an hour left. Let's just look at what we're going to talk about, because the rest of this is still mostly use state. We're just talking about these different situations. So use state is going to be different, a little different when we're working with arrays or objects, and we'll show that here. And then that's what we're showing here. And eventually we're going to talk about rules of hooks. Then we're going to talk about use context, which is like, we'll see the situation for that, but it's essentially a use state that doesn't require us to pass things down through props. And we'll see why that's necessary or at least useful. And that's everything we're going to be talking about today. And use context is really optional. So even if we don't get to it, it's okay, but we will get to it. And then we have the assignments. So that's what we're going to be doing for the rest of the day. Before giving you guys another small break, I know there was some questions, Chris in particular, let's get to that. So questions about, Della is asking, controlled is not a keyword, it's just a concept. A controlled component just means you're passing in the state or the ability to change the state as a prop, as opposed to it's defined at that level. So the idea is that if I have a regular checkbox, it's checkbox that controls checkbox. So checkbox has the use state, etc. Whereas if I have a controlled checkbox is just getting these passed in. It doesn't actually have a use state. So it's app that has the use state. App is controlling checkbox because app just passes in the data. If the data ever changes, app is the one that's re-rendering control checkbox. This is going to make more sense when you have hands-on time with it, which you will have during the assignment. Any other questions though about, I know Chris in particular was mentioning he had a question, right? I don't think I got to that.
You did. I ended up asking later. It was about the event list.
Right. Okay, yeah, we did, I guess. But yeah, any other questions about this? Like what we spent time on so far, which I think it's worth spending this much time on it, is the essential functionality of use state. And just so we can see this, you could have more than one. So like, let's say I had just that first checkbox. There's nothing stopping me from having another use state. So you could have more than one use state. And in this case, I might have it be like input value and set input value. And its initial state would be an empty string. And then, we have this one input, but maybe we have another input. Its type is text. Its value was input value. And on change, might want to make these a little more readable. Went back on me. In this case, I want to build it out because this one is going to be a little more involved in that I'm going to put a function in here. Oh, I guess I could just do it like that, right? This one was the on check change callback, and I'll do this on input change callback. So in this case, it's almost identical, but I have the on input change callback. It takes an event just like the other one does, but in this case, we want to use the event. So the event or what is in the input is always going to be an event.target.value. And then in this case, we would say set input value to that, to event.target.value. And then, you know, we could print it down here just like this, where I would say something like, you know, pre, and I would just put that input value right in there. Save it. So now looking at this, this still works, but we could have more than one use state. So now as I type this, it's going to be reflected below. And if we were to look in the components thing here, what you'll see is that seems stuck. I don't know why it's stuck. There we go. It's aware of two hooks, false and empty string. And as I type, that's going to update. But yeah, so you could have as many of these hooks as you want. Oh, looks like it could even get their names. Cool. So yeah, I want to give you guys a short break and then we'll come back. Any other questions before we take that break? Okay. And if some of these things are unfamiliar, like checked or value, that comes from just like, these are things that are already in HTML. It's just that much like CSS, there's so many things that are theoretically in HTML. You just kind of have to learn them on a case-by-case basis as you encounter the problem where you have to use it. But we're doing that now. Okay, let's give everybody a 5-minute break. Let's come back 11:05, and we're going to cover some of these other things. Okay. Now, where's Jake? I don't care all that much if people are on camera constantly. I'm just happy it's like the standard. I'm not paying super attention. Cool. So I think the next thing we want to talk about is this name list. So I'll put that in there. And we'll look at the contents of it in a second. Name list. Let's just see what that looks like. So I have a name list, right? Ben and Francisco in there initially. And I could say Della. Yeah, I love that when I say someone's name, they suddenly look. I can say Ivan. Let's see if the same thing happens. There we go. He looked. Very funny. Right, so you add someone's name. Pretty straightforward. And we're just seeing it here. So the question is, how do we get something like this? It's going to be pretty similar, but we'll see what it's like. So as you see, just a regular component here. In this case, not a controlled component. I'm going to have everything controlled within namelist itself. So we're not even passing it any props. And then let's see the definition of namelist. So how does it work? Well, here I have my use state. And then the first thing I'm doing is I'm creating this list called names. And then I'm also, I have my sister function set names to update it. And I gave it an initial list of Ben and Francisco, not empty. Could have been empty, but just to show you that that initial list can have whatever you want, including stuff already in it. So to refresh, right, it starts with Ben and Francisco. And let's ignore this part for a second, the input text. Let's just see, okay, we have our div here that we're returning. My div has an input in it, has a button in it, and it has this UL listing all those names using map. So that's how we're seeing our map, and that's how we're seeing our input. But notice what I did here. My input is going to be using an input text value, like we just saw before, and the on change will update that input text. And then my button calls something called add name handler. So why are we doing it this way? Well, this input text is a use state over here, and it's starting out empty. And because of how it's set up, input text essentially represents that input text box. So this input is going to have a value of the input text, and whenever it changes, we're going to update that like this. And then naturally, that's going to trigger a re-render. So now the value will represent that new value. And we can see that happen. I type and it updates. I guess if we want to see it happen, maybe let's just print that out. So we're ignoring add name handler for now. And I'm just going to console.log the input text just to see that every time we type, it is updated. And you know what, actually, why even type it when, let's say right below the input, or maybe below here, I could just, open up a little pre or something. I like pre, and we're going to put the input text there just to show that every time I type, it is indeed updating the input text, and it'll be reflected here. So it says hello right now, refresh now, it says nothing, hello world. Every time I type, it's keeping track of that. So why didn't I make it so that every time I type, something is added to the list? That's because sometimes the input is a little separate from what you want to do when the input's done, because that on change is going to trigger every time I type. So what I actually want to do is say, okay, update the on change every time I type, including, getting rid of stuff and going back to 0. Whereas add name is going to be a specific button that triggers some functionality. So what is the functionality add name triggers? Let me look at it. So that's this button here, on click, add name handler. What does it do? Well, what it does is it creates, we'll see why we do it this way, but essentially we're creating a new list with all the old names and then the input text. And then we're going to print that out. And then we're going to set names to the new list. And then when I'm done, I'm actually going to set input text to be blank because I want to blank it out. So what that's going to do is that now that I'm here, if I say, Grace, and I do add name, once I add the name, it added it here, but it also blanked out this input text because without that line, it would stay there because, that's how it's set up. It doesn't know we want that behavior. So if I didn't have this in there, there's no reason why, after writing Nick, if I click add name, well, Nick is going to stay there because that's, how it's set up. It's set up to always reflect whatever input value is. So what we're going to do here is we're kind of separating things out a little where when I say Nick, that's going to update the input value. When I click add name, that's going to add it to this list represented here. And that's going to blank out the input value if I had it in there. Yeah. Let's try that again. So right, when I click add, it's going to add it to this list and then blank it out. But we actually want to dig into how we added it to the list because this probably looks a little funny. Like, why did we do it this way? Why didn't we just say, the original name for it was names. So why didn't we just say something like, let's try this. We're going to take that out for now. I theoretically, why didn't I just say like names.push? The new name I want is input text. So names.push input text, then set names to whatever names is, and then set input text to blank. Let's see if that works. Okay, here I say Nick, add name. It did work, which is surprising to me. It did work. That almost makes me, did they update React to account for that? That normally doesn't work. And the reason it normally doesn't work is that names is a list and complex data like lists or objects are references. And when we push something onto names, it generally doesn't know that anything changed because names did not change. Names is still referencing the same piece of memory. It's just something was added to the end of it. So I'm surprised that this works, and I'm kind of happy it works because this is such a more natural way to do it. But this is part of the reason we even talk about functional programming, because part of this whole functional thing is that it doesn't play so well with lists and objects and other things that are passed by reference. So what we normally do is something more like this, where I suppose I could take that console.log. Well, no, I don't have to take it out. We normally do something like this, where let's say when I do this, I'm initially going to print the names. Then I create this new variable, updated names, and then I use the spread syntax to say, take everything in names, spread it into this new array I'm creating, brand new array. And then at the end of the array, add another thing called input text and call that updated names. And then finally, set names to updated names. And what we'll see there is that what we print the first time is the original names. And what we print the second time is the updated names. And in this case, the names is not destroyed. It's just we use it to create a new thing, and then we set names to the new thing. So seeing this happen, original, updated, let's do another one. Original, updated. So that was the normal way to do it, and I'm surprised the other way works now. I'm not sure if it works in all cases. I'd be careful with that. But what you generally do in React to make sure, because I guess the important point here is that set names will not actually re-render anything if the data passed to it is identical to the existing data. And that makes sense because if you pass to set names, let's say we didn't have updated names. Let's say we just passed names back to it. It already had that. So why would it re-render? That would be a waste. And you might have situations like this where you click something, but it turns out nothing actually updated in that case. Like let's say you had a situation like this where you had like, it was blank to begin with. And let's say you wanted to make it so that it doesn't actually update in this case. Well, if it's blank, maybe you just don't add anything. And if you don't add anything, you could still call set names, but the data didn't change. So why would it re-render? And so the problem I'm used to is that if we just update names itself and then call set names, we know that the data updated, but the reference didn't change. The memory address is identical. Therefore, it doesn't know to re-render. And so that's why you do it this way. And this could all be made, like there's a couple ways we could do it. Like we could do it like this, where we just put that right in there. We just say, set names to what? To a new array with names and input text. Another way we could do it is we could just, say, copy. And copy is going to be equal to names. That's one way of copying it. There's also like array.clone or something. And then once we have that copy, that is a new array. So we can push input text onto it. And then we set names to the copy. And so that will work. But I mean, this is no guarantee. I would want to look into it more because this really is new functionality I'm not used to. It looks like React might just handle this for us already, where React seems to understand at this point that if I take names as it currently exists and I push something new onto it, and then I set names to names, but it's now updated, it seems to understand that at this point. And that's pretty cool because that makes things as simple as possible. But I'm going to look into this after because that's really new. Like that is not the normal functionality. Normally you have to teach this kind of tricky way of doing it to handle the fact that, it won't recognize that the same array has updated because it's the same array. It's just what it holds has changed. So that's something I'm going to look into after this, but the original way, this will always work. And the reason why this always works is because this array is a brand new array. We spread the existing elements onto it, but because this is a brand new array, it has a different reference. It lives somewhere else in memory. And so set names will always know, hey, that's not the same array, definitely update. Okay. So any questions about this thing? The name, like working with complex data like an array with set state or useState.
I got a quick question. I don't know if you said this already, but so like you're using set names. Is that like something that came from that useState? Like, can you set anything after that, or is it like specific things that you can use?
What do you mean? Like, can I do another thing here, you're saying? What's the question? Like, where is set names coming from? Did we lose you? Oh, you can't hear me?
Cutting out. Yeah, I was saying like how like you have set names. Can you just use any variable after set, or is that like a specific thing?
Oh, this could be named anything. This could be named XYZ, and then we just call it like XYZ. It's just a common pattern to call it set and the same thing.
Gotcha.
But yeah, I mean, you know, this could literally be like AB. Like you could make your life more difficult by naming these things whatever you want, because that's how variables work. And this destructuring thing is going to say, okay, give the first thing the name ABC, the second thing XYZ. But to make our lives easier, this is a really common pattern where you name whatever you want the variable to be called in the first one, and the second one you just call it set, the name of the variable. But that's not like necessary at all. Okay, good. Yeah. And let me see over here. The useState with complex data thing is where, you know, we dig in on the fact that, you know, working with complex data, and by complex data, I mean in JavaScript, an array or an object, anything that's not primitive, like a number or a Boolean or a string, because those by default, any change to it is recognized because it's always a new thing. But what I was used to is that this doesn't work in terms of working with an array, and same thing with an object. If the object is the same object, even if some key value pair changed, React used to not be smart enough to recognize that. But yeah, I'm going to look into why that works now. And I'll give you the caveat that it might not actually work in all cases. It could just have worked in that case. So might want to be careful there. Something we don't go into is there's, I have another file here called complex state. So if we look in here, there's another thing after name list that I called complex state. I just have a bunch of, basically, I'm using this to, I guess we could see it. That's probably worth seeing it. So in this case, I have the add name like I did before. But I added some stuff. So for example, when I try and click add name here, it doesn't work. We say can't add empty string. Similarly, we have this rental, which is represented by an object. And let's say I want to change the title of the object. Well, if I do change title, it also doesn't like that if there's nothing in there. And then maybe I change it to hello, and then it does update. So yeah, let's see those two features, both working with objects and also this, you know, guard to make sure nothing happens if it's empty. So yeah, we have two useStates here like before, and these useStates are going to represent, because we're using buttons, these are just going to represent the on changes for the name input and the title input. So that's here. This is the name input. This is the title input. And I have those useStates just to represent the, you know, every time we type, that's going to update that input value. And then I have two more useStates. You can use as many useStates as you want. The first one is to represent the list of names. And when we click the button, we'll take whatever was currently new name input and update that. And same with rental, it'll be updated by new title input. But in this case, we're working with an object. So we're going to see how we work with that. So we'll ignore these for now, just jump down to the JSX. That's a pretty common thing that the first thing you want to look at when looking at a React component is the JSX. There's a fair amount going on here, the names, where we list them. And now add name, on change, we're going to update that new name input. And then we have this button here where when we click it, we call add name. And why did I write this? This is incorrect. Oh, this should be here. Oops. Yes. So right, the input is going to have a value we want to associate with new name input. And every time it changes, we'll update, that change will be reflected through calling set new name input. And then the button will call add name. So what happens when we call add name? Let's look at it. Well, I have guards. So guards is not a unique React idea. It's just this idea that I don't want to do something unless the right situation occurred. So first I'm going to check, well, that new name input, is it empty? Because if it's empty, I don't want to write anything. Let me print an error to the console. And then nothing happens, but I do. It looks like no matter what, I'll reset the input. So let's see that over here. I'm going to say hello. Well, actually, no, I'm going to say nothing because I want an empty. If I click add name, that first guard triggers, can't add an empty string. This second guard shows that you can have more complex guards. So in this case, I'm looking through the names. I'm trying to find anything. I'm using this find index function to find anything with a matching name to the current input. And if that found something, it will return me the index. If it can't find it, it'll return -1. So I'm saying only in the case that it can't find that in the existing array do I, no, actually, yeah, as long as it's not -1, I'm saying print this, because if it was any number other than -1, it would mean we actually found that in the array and it would give us the index. And in that case, I want to print can't add existing name. It's only in the final situation that I have my valid case and I say, okay, if neither of these guards were true, now I actually want to update name with that new name, and then no matter what, I blank it out. So what that looks like is that if I add the name D, that works. But if I try to add the name D again, it's not empty, but that second guard triggers, can't add existing name to list. That's what I want. Now let's look at the rental thing. So how does that differ? Well, if I look down here, I have my rental. I have some style here, doesn't really matter, but this is a way you can do inline style. You just pass it as an object. And it looks pretty similar to the CSS version. It's just we have to wrap things in quotes because it's JavaScript. Okay, so I'm printing the title, the year, the rating, right? And now I have this input, and when it changes, we update the useState for, I put these in the wrong places both times. We also want that, right? And then only on the on click are we going to then use it. So of course, before we click the button, nothing in the title is going to change. It's just going to update this new name input state. But then what happens when we click it? So when we click it, we run this callback. This one says, if it's empty, do nothing, and then return. So you could always return early, and that's a way of doing nothing else. And then I'm saying, assuming we didn't end early, this is what we want to do. And it's very similar to the array case, but with an object, we can also do this spread thing where we create what looks like an object. We spread all the key value pairs that were originally on the object. So the object already has, if we look at our object, it already has an ID, title, year, and rating. So all of that is going to go back on this new object through the spread. But I can give it a final key value pair, title, new title input, which was our input text. And the thing is, when we spread it, it already had a title, but because this title comes after, it overrides the other key, because you can't have two of the same key in an object. So because this one comes later, it overwrites the first one. And so this will work now, where if I start typing here, I type hello. Wait, it's not working. Get some stuff out of the way. If I start typing, it doesn't seem to like that. Why not? Let me look back here. New title input. That's the problem. Okay. So its value should be new title input. I think it was upset because you can't have, like, I don't know. I'm not positive, but let's see. If I start typing on this now, it works. I click change title. The title actually does update. So yeah, that works as expected. And now I'm just curious. I see people are asking in the chat. I maybe could take those off if you guys don't like them, but I know that my, triple equals and not equals look kind of funny like this. This is it's just a visual feature. It's called ligatures. It basically makes it so that if I were to write, less than or equal to, it makes that into like a fancy Unicode thing instead of the regular ASCII characters. It's really not necessary, and it can be turned off pretty easily if I said like ligature. I don't know. It's an extension. It's not necessary, but you guys can give me feedback if you like or don't like them. But that's all it really is. It's just the triple equals or the not equal. Just makes it look fancier. I'm just curious for my own sake now. When I did, just like before, when I worked with set names, like I didn't expect that thing to work, but if I do this here, instead of spreading it like that, if I do, names.push, new name input, and then I give it names, that worked last time. So let's see that still works here. And it does. So let's see if that also works for the rental. In the rental case, I was doing the same thing with the spreading, but wouldn't it be simpler if I didn't have to do that? So if I take this out, and before doing that, what if I just say, okay, take the rental and then take its title and make it equal to new title input. And now set rental just to rental, right? Because something changed. Let's see if that works. If React is all new now. So hello, change title. Wow, that's amazing. React got simpler since I last checked, which is great. Because now you don't have to work with these patterns. Apparently, I'm going to look it up after to make sure we're right, but you don't have to necessarily use that spreading pattern anymore. It seems to be smart enough to know if something within a complex object changed, if it's not the exact same object, it will indeed trigger set rental to, or your set function to update the state. So that's really good. Good to know that. Okay, so that's it for complex state. And the last thing we're going to talk about, I guess that's actually all we're going to do to talk about useState. So before moving on, any questions about useState as we've seen it? Fair enough. I mean, you'll get more practice this afternoon. Looking at the next section actually is rules of hooks. So I linked to the actual, I guess what is now the outdated docs, but this is explicit about the rules of hooks. So there's actually rules to using hooks correctly, because there's some situations you can get in it doesn't like. The main rule is this though, only call hooks at the top level. What does that mean? Don't call hooks inside loops, conditions, or nested functions. So essentially for React to work correctly, it needs all your hooks to be called in the same order every time. That's why if we look over at, where do we have it? Didn't we have one of these open? Did I close it? Yeah, like let's say we turn this back on, complex state, we come back here. If I look in here, you'll see that React is not thinking of Yeah, React is not thinking, it doesn't always work. It's not thinking of these different hooks in terms of their names. It's thinking of them in terms of their order, 1, 2, 3, 4. It wants them to be the same order every single time. And because of that, because that's how it keeps track of hooks, you can't run them in a different order. And that means, as a result, when it comes to hooks, they have to always be called at the top level and therefore in the same order. So you'll notice when I say top level, I mean, this is my component. I'm calling useState at this level, same level, right? But what I can't do is make some function where I say const, or sorry, I say like, if I had like a function, call useState, and inside of there, I tried to say const x set x equal to useState 1. And then after that, I tried to say call useState. React would not like this. And obviously, how would I get those out of there? But maybe I return them, right? So I'll return x and set x. And then maybe over here, I would say const x set x. React doesn't like this. I wonder if it'll yell at us right now. So I think it will. No, it won't. But basically, this breaks the contract of hooks. So we're just going to look at this in the notes now. If I look at my notes, I'll see that there's a couple situations we want to avoid. So we only want to use hooks at the top level only. No, it should be top level only. But right, so for example, you can't do this. You might hope you could do this where you have like, 2 values and then you actually use the states inside of conditional. But this means that every time you run it, it might be a different useState or in a different order. It doesn't like that. Same with this, you can't run it within a for loop. Same with this, you can't run it within a function. So the basic rule is you only use states at the top level. Otherwise, the behavior is what's called undefined. And you'll see that a fair amount in the world of programming at large. Some things are illegal, right? Because if you try and do it, the compiler, whatever it is, will yell at you and say you can't do that. Other things, it's actually much worse, are called undefined. And what that means is we can't really detect when you do this, so we can't call it out, but you're breaking the contract. You're breaking the verbal contract. And because of that, we can't guarantee it's going to work as you expect. There might be situations where it does work, but there might be situations where it does not work as expected. So basically, React is saying, if you decide to use a hook and it's not at the top level, we're not responsible for the outcome. You didn't use it correctly. And so the important point there is that you never have to use a hook in a for loop, in a conditional, inside of another function. There's always a way to use it at the top level. You might have to Google and figure out, how do I do this in the way I want to? But if you're trying to call a hook, and a hook is always something that starts with use, if you're trying to call that anywhere other than the top level of a component, you're probably doing something wrong. Yeah, Kelvin's right. Straight to jail. React and the US government, they're, it's a tight coupling now. So React can do that. They have that power. I think it's unconstitutional, but Mark said it's a good idea. Okay, so the final thing we're going to talk about today, we have another like 23 minutes, and it's good use of it. It's this thing called use context. So use context is very similar to use state in that it's about passing state around. But to see why it's useful, first let's look at this example of of a problem, not necessarily a problem, but an approach to passing state around called prop drilling. So if I come back here to my app, I'm going to comment this one back out again. And what I'm going to comment in is this thing called prop drilling. So what is prop drilling? It's just another component. I'm giving it something called label. I'm passing in, from up here, the checked and set checked at the level of app. I'm passing it in like checked and set checked. So just like I did with the control checkbox, I'm passing all this data in because let's say I want it to live at the level of app, other things need access to it, but I want to pass it to this component I called prop drilling. So now let's open that component, prop drilling. What does it look like? Well, prop drilling is a component. It takes these props, but it itself relies on another thing called prop drilling level 1. And because it, wants to pass this data on to these lower levels, we pass it as props. And then I click on prop drilling level 1. And that itself relies on something called prop drilling level 2. And it has to do the same thing. It unpacks all those props and then it passes them to the next level. Keeps happening. I hate that. So I click that. Now, finally, at prop drilling level 2, so 3 levels down, we unpack it, and now we finally use it. And as we'll see, this does indeed work. But it kind of makes our code a little ugly in that because all we have for passing state down right now is props, we end up in this situation where I defined it at the top level, and you'll see that pretty commonly in apps that, you want to define something at a level that all the things that care about it can know about it. And so depending on what the information is, you might have to define it at the very top level and then share it theoretically with every component. And so the way we have currently to share it is props. So we have checked and set checked. We pass it down to this component. This component doesn't use it directly, but its child does, so it passes it down. Even this component doesn't use it directly, but its child does, so it passes it down. And then finally, at this level, this component uses it. So this is sometimes considered a problem. It's also just the name of a technique. What we did is called prop drilling. So just like a drill, we're going deeper and deeper and deeper to these, this component references this component, references this component. And basically if app, so this component, let's say is the child, this component is the father, or sorry, this component is the child. What is this component? It's called prop drilling level. Did I even name these right? Something. I don't know if I named these right, but either way, I have a couple of levels here, right? So, right, this one's called prop drilling level 2. I did name them right. Okay, this one's called prop drilling level 2. It's like the child. Prop drilling level 1 is the father. It references the child. So like prop drilling level 2 is a child of prop drilling level 1. Prop drilling level 1 is itself a child of prop drilling. So prop drilling is the grandfather. And prop drilling is itself a child of app. So app is the great-grandfather. And it's like if the great-grandfather wants to pass something down to the grandfather, wants to pass something down to the father, wants to pass something down to the child, the great-grandfather has no ability to pass directly to the child. You have to go through these subsequent levels because by design, React only allows you to pass props to the children. That's all you have access to. And then the children could have their own children and the children could have their own children. And this might seem medium, annoying when you have 4 levels. But if you're writing like Facebook itself, and that's what really powers all the good changes to React, that Facebook itself is written in React, which I think is a good thing because Google doesn't write any of their own essential stuff in Angular, but Facebook does write all their essential stuff in React. And as a result, they run into these problems pretty quickly. And they might have a component, where there's like, a component hierarchy of, 1,000 levels. And it could be that something has to be defined at the very top level, but 1,000 levels down, something needs 100 different props. That's going to be really annoying to explicitly pass down at each level. It's going to get really cumbersome. So there's got to be a better way, right? So just reading the chat right now. Ivan is asking, is the state for this at prop drilling level 2? So Dell is asking what the common use for prop drilling is. The common use is just that things go down levels and levels and levels. So, I mean, I can only use my example right now because I don't want to like go to Facebook because it's much worse. It's a much worse website than my website. But basically this is the use case, which is just like the data is defined here because maybe lots of other things share it. And a real world use case would be like, let's say you have a theme, right? You have a setting where someone can choose dark theme or light theme. That's going to affect every component on the entire site. Every component's going to have to know about it. So it's going to, if you have lots and lots of levels, it has to be passed down from the very top all the way to the bottom. And you just have these levels. So I have to pass it down. So app has no props. Prop drilling has 3 props, but it doesn't use them. It just passes them down to prop drilling level 1, which just passes them down to prop drilling level 2, which finally uses them. And this is just 3 levels, but it could be 1,000 levels, you know. And if we looked at, I don't want to go to my own Facebook. I don't even know if my own Facebook works. Can I just see like an example of Facebook or an example site that uses React? There must be some. Does anyone know, like, what's a large production grade React site? Jira clone. Okay, let's try that out. So I just want to see this Jira clone. So this person built it in React, and I can see here the React thing is lighting up because it's saying, yes, they did. I wonder if this still works. So it looks like it doesn't. But anyways, as you could see, this has lots and lots of levels, right? It has weird names because, there we go. It has weird names because they like minified it or something. But as you could see, there's lots and lots and lots of levels, especially here. Like, I have like, there's just so many levels, so many different branches. So let's say there's some prop that exists at the top level that specific button, right, always needs. We want some other solution. You could see he's actually using, or they are using this solution. So this says context.consumer. What's that? We haven't seen that yet. We're going to see that right now. So when you have lots and lots of levels, sometimes prop drilling is not a great solution. And that's where we want to start using this thing called context. So we're going to comment this one out and comment in this one and see how this works. So first thing we're going to notice, checkbox context. What is that? It's actually coming from here. So I defined it in a separate file, and you'll see why. I made a little folder called context. If I open that up, there's one thing in it, checkbox context. So let's see what it is. It's really basic. You're going to see in a second why I have to define it in another file. But what we're doing is first we're including a function built into React called create context. We're going to create a context that we name checkbox context, but we are going to initially give it a value of null. And that's generally what you do. So this is its initial value, but it's going to be null. And then we just export it. And so what that gives us is that where we call it over here, we have this thing called checkbox context. And because we used, you know, create context, we now have the ability to do this. So checkbox context is actually a component. And unlike most components, it has this thing .provider. So you have to use it this way. And it's only for historical reasons we have .provider, as opposed to it just being, you know, like that. But we say, you know, the name of our context we created, .provider. And then where I had that null before, I can update that with value. So value is a single prop it takes. These first curly brackets are just the escape thing. And then what's inside is an object. And I could put anything in there. I could just put the value 4 in there. And instead of it, you know, passing around a value of null, it will now pass around a value of 4. But I actually want to pass it around a value of this entire object. And this object is, you know, a label, checked, and set checked, which are all coming from this level. So now I'm passing my state around through this thing called a context. And the way a context works is that here's the context, it's opening, and here's its closing. And then here it has a child, a context-aware checkbox. And so even though I'm only doing it at one level here, it doesn't matter like how many levels this is. I guess I should probably show that, but this context-aware checkbox, let's see how that works. Well, that is now going to take two things. First, it's going to grab a hook called useContext, and then it's going to have to know about that specific context we talked about, because there might be more than one context a given component is aware of. So what we do here is we call useContext at the top level with that specific checkbox context. It's going to get anything from here, which we made an object. So then I get that object when I call this, and then I immediately destructure it to get some stuff. And then like normal, I just use it. So this will work right now. And you might say, why did we go through all this trouble? That's because unlike the prop drilling approach, and I guess I can make this right now, like I made a context-aware checkbox, right? But what if I did something else? What if I said, I'm just going to make something I'm going to call level 1, and I'm going to have to make these on the fly, so it's going to take a second. So let's say the checkbox context is not there. You know, I can include it there, but the point is I'm not using it. All I'm doing is, you know, I have this provider, and then what I'm actually rendering within the provider. So everything within the provider is going to have access to that context. I'm ignore the phone. I'm sorry about that. Give me a second. Sorry, give me a second. Sorry about that. Right, so here's my context. Everything inside of it is going to have access to it, but only what's inside of it. So I have this level 1 component. I actually have to create that now because I don't have one of those yet. So let me make a new file called level1.jsx, export default function level 1. It's going to return something. What's it going to return? Well, I want it to return a level 2. And so I'm probably going to have to do this a couple times. Let me just say level 1, level 2, level 3. That's enough levels. Make sure I name these right. So I'm going to do it like this, where we're going to have our level 3. We'll figure that one out in a second. Level 2 will look like this, and it'll just import level 3. And we're going to turn there is level 3. And then level 1 is going to import level 1. No, sorry, it's going to import level 2. I'm getting confused. Return level 2. So I'm just doing this to show you how we might work with this. So if I go all the way back to app, I want app to actually show level 1. So I'm going to say import level 1. Okay. And I didn't pass it any props. I just put it in the context. So I look at level 1. In reality, level 1 would have more things, but I'm just returning level 2. I look at level 2. Level 2 just returns level 3. So I didn't have to pass any props around. I finally get to level 3. Here's the place where I'm saying, okay, import context-aware checkbox. Now I could say return context-aware checkbox. So even though it's all these levels down, because that first thing, because if I look at app, so we have our checkbox contents, level 1 is inside of it, level 2 is inside of that, level 3 is inside of that, and then finally checkbox aware context is inside of that. So even though they're separated all this way, the fact that that checkbox aware context is ultimately still inside of and therefore aware of this checkbox context provider means that it's able to use that context. And so this should still work. And as we see here, so it still works, but what's cool is that there's all these levels. It's the provider that actually has that checked value. So when I go on and off, that should change. It takes a second, but it does change. Level 1, level 2, level 3, they don't have any props. They're not using any hooks. They're kind of, very empty components. That final level, because it's using that hook, it has access to that context. And so even though the change is happening all the way up here, we're actually able to access the result all the way here. So that was a lot just to show that. But the point of context is just that if you know you're going to have multiple levels, you might as well share it with everything below. And so it's not an uncommon pattern to say, I'm going to define all my level at the very top in app, and then I'm going to create a single context that just has access to all the data I want the entire app to have access to. And then everyone has access to all the data using the use context hook. It's ultimately not a smart way of doing things if you want to separate concerns. But if you're just building something, it's a really easy way to make it so that every React component you have, no matter the level, has access to any of the data it wants, which is all defined at the top level. So that's a fair amount. Yeah, I know. Just looking through the comments now. Yeah, a lot of major companies use React. It really is. I mean, I'm sure there's some Angular diehards still, but try and learn Angular. It's terrible. React is really the most straightforward way of representing this problem. I would go as far as to say they solve the problem of the view layer. So, there's a lot of problems you could possibly encounter in a website, but one problem is given some data, how do I make the page look a certain way? And then if there's ever changes that, events that occur on the page, how do I then update the data so the page reflects it? And React has solved that problem. I see Noah saying that they're not sure if they're a front-end sort of person. Everyone does tend to have a preference, but you'll see. And you can pass multiple contexts. Yeah, exactly. So the whole reason that you have to do the context stuff in that way, which is a little confusing, is that just like I have a checkbox content, I could have, something I'll call different context, and I might want to name it like that. But then as a result, I'm still making it null. As a result, I could X all these out. I have a lot open right now. As a result, I can do the same thing where here was my checkbox content. Just as well, I could say import different context from different context. And now this different context can take a different sort of value. So just like I wrap this whole thing in this provider, I could say, okay, well, actually we have different context.provider. It's going to have its own value. And maybe I'll just make that value 4, right? Why not? And then I want to make sure I wrap all these, but I could have as many providers as I want. And then I'm going to do the same thing where level 1 doesn't need to know about it. Level 2 doesn't need to know about it. Level 3 doesn't need to know about it. Now our final level, context-aware checkbox. Okay, this one, I'm going to say, actually, I want you to know about the different context. That's going to have a value on it equal to 4. So now here I could say const number, because that's what I gave it. Use context. The context now is different context. And then we can have something here where I say my fave number, and it was this number I passed all the way down. And I would expect that this would work. Let's see it. Yeah. So as we see here, this context was providing the checked, set checked, and label. This context was providing the value 4. These don't use the context, but still they eventually end up with a component that does use context. And this first context, so that's again that whole thing of the top level, they happen in order. So this first context represents these things that came from the checkbox context. This next context represents whatever was passed to the different context. And now it has access to that data. And so that's a way that you could split things up to say, okay, anything, you know, with this concern, we want to make sure that it has access to this context, but then, you know, maybe there's another, like you might have a theme context. That's pretty common. And then you could have different data wrapped in like a user context. I don't know. But it's just a way of sharing the data from a top level component to a very deeply nested component without having to use props to pass it all the way through, because otherwise that would be the only way. All right, so I know that's another knowledge dump. But the assignment for today should hopefully help us understand this stuff, and I'll, you know, jump around today like yesterday to make sure we're absorbing it. So coming back here, you know, and this is all, you know, spelled out in the curriculum doc, as well as the cheat sheet has all this information if you ever want to see the specific pattern. But this is what we're going to be working on today, video store part 2. So let's just open that up. Let me grab that. And this is going to be pretty similar to yesterday. So you see we have slightly different goals here. You don't have to use context here, but you could if you wanted to. But the prop drilling would work fine just because it's only a few levels. Though I think my solution used context just to show it. So now if I go here, clone this. So we should be able to see this. Don't worry about these vulnerabilities. Cool. So opening that up, you'll see I have the starting point of yesterday, essentially. This is out. If I click this, it says like, you know, you currently have 4 copies, and our goal is to make this actually work. So if I come back here, I provided the solution branch again, because I think that's useful. Going to run that. Now we'll look at it. It looks basically the same, but what changed? Okay, so first, I'm surprised my CSS is oh, there we go. Okay, that looks a little better. What changed? Well, first, when I click one of these, we actually see a details view below it. It's not a different page. It's on the same page, but we're going to optionally show this details panel whether there's a selected film or not. So initially there's no selected film, and we recreate that by clicking this button. Now there's no selected film, but when we click any one of these films, we're going to see the currently selected film. That's going to give us a few more details, and that's going to give us these buttons, which will be disabled if appropriate. But if I click return, that number increased. We can keep doing that. But notice that this number is now, you know, originally it was 0. Well, here it's 0. Now we're going to return it twice. It's also 2 over here. So that might seem like a small thing, but that's the big feature we're building to. Not just that, you know, there's now state, but the state is not totally contained to the one component. The state is shared throughout the app, because that's usually the case, that you want to maintain a single source of truth that the whole app is aware of. And that's essentially what we're going to be building today. So that's going to require you to start from the starting point and do a little bit of refactoring, in that we started at a certain point, and we're going to, you know, first have to break things a little in order to add in this new functionality we want. But that's by design, because that's closer to a real world thing where you sort of build up to a certain stage. You know, yesterday we had this like minimum viable product. Well, now we want to add a feature to it, but adding that feature will probably involve having to break some of what we built yesterday in order to add the new stuff, hook it all up, and now it works. So there's some, you know, suggested steps here for how you might want to go about doing that. But you'll have access to that solution branch if you want to look at the solution. And yeah, that's what we're going to be doing today. So we'll be coming back at, when is it? What is 2 p.m. CST? We're going to be doing pairs today, so I'll make sure to set up the pairs. And yeah, it is lunchtime, I believe, so you're free to go. But I will stick around to answer any questions. You have the link in the assignment. And yeah, I'll be back later. So any questions before we break for the day? I see Kelvin asked if use context is still considered prop drilling. Well, no, just because the word prop drilling implies you're using the props to do it. But like prop drilling doesn't need to be a negative thing. It's just that's a certain technique. It just requires, and it's the built-in technique, it just requires you to be explicit, passing stuff at each step. Whereas use context makes it so that you don't have to do the drilling. You can just pass something from the great-great-grandfather right to the great-great-grandchild. And they're just, they're aware of each other without having to go through each of the intermediate parents. And honestly, all context really gets you is that you're getting to clean up your code a little. Prop drilling totally works. Don't feel like you can't use that approach because it's only a mild gain to clean up your code. It's just that if you have lots and lots of props and you're passing them down lots and lots of levels, you're probably saving a fair amount of, like it's not just characters you're saving. It's your own mental effort of seeing a screen full of stuff versus seeing a screen where there's only what's necessary for that component on it. And lecture will be posted on YouTube. I just need to get off of here, download it, upload it, make sure it actually uploads. Yeah. All right, anything else? If not, I will jump off and start downloading. And then there was Eric. It's the only face I still see. Cool hat. Kansas City? Yeah. I'm sure that's a team. I don't know anything about sports, but
Kansas City came over and like they had their staff. They came over to check out our equipment and stuff. So we're like showing them our engineering equipment.
Which Kansas City is this? Or like which team is this?
Kansas City Chiefs.
Okay, and I'm curious, do they play for Kansas City, Kansas, or Kansas City, Missouri?
I think it's Kansas City, Missouri, to be honest.
Yeah, isn't that funny that Kansas City, Missouri is the real Kansas City?
Like, yeah, it's so from what I understand, it's like one hub, but they're like split by the state line, basically.
Yeah, Kansas City's a very silly situation where it's like that should have been one state. Come on, but they both wanted Kansas City.
Yeah.
Yeah.
Thanks for the lecture, Ben.
Oh yeah, no problem. What's up, Dennis?
Hey Ben, I have the issue of the environment.
Okay, you want to share your screen or?
Sure.
Okay.
So, every time I update the app here, and my browser cannot refresh automatically.
I see. It says unchecked runtime. Okay, so you're saying that you have to manually do it. Like if you were to refresh this.
Yeah, every time I need to refresh it.
Well, so can I see that? Like first refresh localhost 5173. Just to get like all the errors gone. I guess those errors are happening every time.
Yeah.
I've never seen that error before. Runtime.last server cannot establish connection. Receiving end does not exist. Okay. Okay, so now you're telling me that if you just added something to that page, it wouldn't, let's see that. Like just add a line to that page. Anywhere. Like it could be a console.log, it could be, we just want to see that when you click save, we're getting some issue. Okay.
So I save it.
And yeah, I see nothing. It doesn't know. It doesn't. Yeah. So why is that happening? It's hard to say. So the feature Vite is doing for you is called like watching. That means it's watching your files, and if a file changes, it knows it changed, so it refreshes things for you. It's not a necessary feature, but you probably do find it annoying that you have to keep refreshing it. I'm not sure why the watcher isn't working. We can like Google it. Like I would just Google like Vite watcher not working. So here's something for us to try. Where you're running Vite, type Q, like quit out of Vite, right? In the terminal. Great. So now if you write npm dev run, but don't hit enter, okay? So that's going to run the command Vite, but Vite, you know, because if we looked in package.json, that's what that links up to. But you can actually pass it specific arguments. So give it a space, and then do dash the word watch.
Log.
Dash.
So is this one also under this one?
No, regular dash. Yeah, not under. Regular, yeah.
This one.
And then the word watch. Yeah, and then space. And then do /source. Try that. src, because we wanted to watch that one file for changes. src, just like the actual file in your space. Yeah. So now hit enter. Oh, sorry, that should be npm run dev. So do that all.
Oh, yeah.
Flip those words.
Not automatic interval.
Okay, well, what happens if you refresh localhost 5173, like in your browser? Does it work at least? It does not. Okay, so let's try that again. Do Q, quit out. Press up to go back to the same thing. And now take out src, just do // or just dot. No, just dot.
Just dot.
Just dot. Try that. It's also not working. Nope. Okay, let's try it now. So refresh your page. Okay, now let's try to see if when you make a change, something happens. So change the 1, 2, 3, 4 to like, 5, 6 or something, or that. Yeah. Still not picking it up seemingly, right?
Yeah. And refresh, here still nothing. So every time I need to quit the terminal and run the dev again.
And what operating system are you
on? Windows.
And you're using WSL?
Yes, WSL. Maybe there's something wrong in the WSL.
Well, I'm trying to move something from my screen so I could see. I can't see it on your screen because mine's covering it, but I shouldn't be recording.